Okay, let me. Oh, what? You want me to go on? Yeah. Oh. Okay. Yeah, no, I'm okay. See, it's good to buy. Yeah, well, yeah, some concepts. Yeah. What? Oh no, yeah, you just Yeah, oh, okay.
Good morning, everyone. Can you ask people to move away from the door, either in or out? And if you're moving in front of the beamer in the back, please do it elegantly so that we don't see you on screen. And then finally, please do not plug anything on the beamer panels because this is going to actually cut the connectivity. So do not use the beamer there to plug your own computers. The beamer in the back, do not plug your computers on it. We're just running a bit late, but we're ready to kick this session. So please take your seats. No, it's not. To use the clicker, tell them that they need to click here. Sure, and I'm gonna go. Okay. Also notice. Yeah. Good morning, everyone, and welcome to the fourth day of CGIAR Science Week. I'm so excited to see you all here, all packed and full of energy. Though we have one session prior to this, which actually had a soft launch for Digital Transformation Accelerator, I think we all are brimmed with energy now. Sipped our coffee already. So with this, again, welcome you all. My name is Shalini Gakhar, and I'm working as a data scientist with International Rice Research Institute. I'm glad to moderate the first session, the very first session, which is actually the status of AI in agri-food system, research and innovation. We do have very eminent speakers who will be taking us to this journey for sure, and then I'm sure that we're going to enjoy it. So as we start and then give some time to our speakers, so I really want you to close your eyes for like 30 seconds, sorry. 30 seconds. Don't sleep, don't cheat. Or it's okay if you want to take a nap at the last. So yes, so just close your eyes for 30 seconds and feel each and every word which I say. So just imagine that we are standing in a dusty field. You are here, you actually hear a low humming noise, which is there. Probably it could be a sound of drone, which is there gliding like a hawk, scanning every inch of dry soil below. A solar powered sensor feeds real time soil data to an AI system in the cloud. The farmer beside you just got a voice alert in the regional language from her digital companion. Upcoming heat spike detected. Water after sunset. You've adjusted your crop rotation schedule for next season. She smiles and says, I trust the technology. I believe it understands me. Now you could just open your eyes and actually see that it's a reality that probably we are trying to bring it through AI. This whole session talks about this. And then this world isn't a fiction, by the way. So we have the core technologies, they exist already. What we need to work or take leap on is actually it's political, it's social, it's cultural, it's about the will that we really need to bring it together. So this session is not just a panel, but it's a pulse check from the future. So this first session, I'll just invite our first keynote speaker. It's my pleasure to introduce Abigail, a research software engineer with Google AI team in Ghana. She brings deep expertise in computer vision and optimization with a passion of applying AI to global challenges, from agriculture and health to education. Please, Abigail. Oh, great. So with Abigail, Aisha is also here to actually give you a walkthrough about the commitments which Google is seeing in this arena. Please.
That's no problem. Hi, everybody. I'm Aisha. I'm not really fans of speaking to a photo of myself. I actually removed that slide. That's okay. Good morning. How are you all? That doesn't sound good, and then I don't want to speak. Good morning. How are you all? Amazing. Thanks so much. We can move from this slide with my face. It's so embarrassing. How do we? Try some magic. Yeah, super, thanks. So I'm Aisha. I lead our Google Research Africa team in Accra, Ghana. That one was established in 2018, where Abigail is from. And then I started our expanded team in Nairobi, Kenya in 2022. I've been here working on AI and tech in Africa more than a decade. My background, I did my PhD in robotics at MIT, and then I decided that I should work with humans. I'm still warming up to all of you all, but the desire for impact and the transformative potential of the incredible work that everyone here is doing on the continent is driving me slightly more than robotics. At some point, they'll all come together. So that's a bit about myself. I am a part of a broader team in Google Research that focuses on climate AI, sustainability, impact-driven solutions for the world. So we look specifically for types of problems where we are best positioned as Google from an AI, from a compute, and from a scalability perspective to focus on that is going to transform the welfare of society. So we have started with flagship work in flood forecasting, which was in like a small village in India, and it's now been scaled to over 90 countries worldwide. So that's the incredible power of the team that I'm on over several years, 5-7 years. You'll see a lot of that work. You can go to floodhub.com or even look a lot of this work up on the internet. Much of what we do, we're getting new data sets, new models, new solutions out to society to impact all of you all, like large organizations, startups, NGOs, private sector, public sector. So any sort of innovative tools that uplifts you all is what we focus on as a team. We also have incredible work on wildfires detection. You guys know most recently there's been quite a bit of wildfires, even in California and many parts of the world. We use our surfaces like Google Search, Maps, and others to be able to provide alerts and boundaries of wildfires as well as floods. We have incredible work on CO2 emissions reduction with Project Greenlight. So it's actually kind of an interesting win-win where you're trying to not have traffic or vehicles sit in traffic for long periods of time. because that also obviously affects the environment. So optimizing stoplights and traffic lights across many cities in the world, scaling that. We have another solution on our broader team called Project Sky that we're working in collaboration with a few other UN entities that work on disaster response. This uses AI for satellite imagery and some of the work that Abigail will deep dive on today to be able to speed up that time of how do you identify who's affected by these natural disasters and how do you get aid to them much more quickly. So we've seen turnaround times down to weeks where it used to be months when you're assessing situations. So we've used it in hurricanes, earthquakes, and many other natural disasters. And then the bottom row is really focusing on our Google Research Africa team. You'll have the pleasure of hearing from Abigail today on our open buildings work and how it has scaled to field boundary detection for farms. And so that shows you how this core technology can be used in multiple ways. I'll do a highlight on our recently launched, maybe 1.5 weeks fresh, weather nowcasting for Africa work. So those of you who use Google search on your phones, if you type weather, you should be able to get weather nowcasts up to 12 hours. That's updated every 15 minutes for your 5-kilometer radius across the continent. This is incredible new work to get those accurate, precise weather measurements for Africa. I'm also leading our food security efforts. Those are much newer for our team, and we work with many of the folks in the room here, and you'll hear more from them. And then we have some very interesting work on African languages with partnerships with universities around data collection and open sourcing those language assets. So again, those are all open and available. Let me spotlight 2 projects. Next slide. So out of our flood forecasting work, remember I said it started really small with a small team, just exploring how AI can actually make an impact in improving flood forecast estimates. And now we've shown that there is a significant difference in a way to scale a global model to forecast floods in the riverines worldwide. Now this work has turned into several different projects and more recently drought forecasting. And I think most of us in this room know how important drought forecasting is. So this focuses on a land surface model to understand where there might be drought across the world. It's fairly early, but it's not too early that I can't share. So to know that for many of you that might find droughts and drought information useful and important for your work, you're welcome to reach out to us on that as well. Next slide. Yes, and this is a little bit more detail on our weather nowcasting for Africa work. Again, it's not focusing specifically on Africa, but because of our Africa team, we were able to integrate into the larger global model. So at first they started in US and Europe where the data was more rich from satellite and from radar, but now we've been able to do some innovations and work with that team to be able to scale in places across the global south and specifically for Africa. We have other weather assets. Nowcasting is about 12 hours ahead. We have other assets that start to look at a more longer term horizon and happy to follow up on that afterwards. But here, what we want to do now, we're at the point where we're ready to externalize this data in collaboration with partners to see how useful weather nowcasts can be. So what is the right way to package weather information, and maybe for farmers, for traffic, for insurance, so various industries. So we're looking from a research collaboration to test how useful and how accurate this can be for your different use cases. And next slide. And I'll wrap here to say that that work has launched. This is an example of the sort of before and after. So on the left, you'll see the rain. This is just a pause basically the rain precipitation levels being forecasted at a specific time point. And you'll also start to get like a bar chart when you look up weather, and you can scroll across and see the chance of rain in wherever your area is using weather on search. And now I will turn it over to my incredible research colleague, Abigail, who has a very rich story and extremely mature, deep AI impactful solutions that should be relevant to all of you all. Thank you.
Thank you, Aisha. Hello, everyone. Good morning. My name is Abigail Anka. I am going to skip these 2 slides and speak briefly. I am a research software engineer with the Google Accra office. I have a background in mathematics and statistics and a follow-up master's in machine intelligence. I've worked with Google as a researcher for close to 5 years, but I started as an AI resident. I was actually part of the first cohort of residents, so I'm proud to have seen how Google supported my career, my journey up to this point. And for today's talk, following Aisha's amazing introduction, I would be focusing on how we can scale agrispatial intelligence. So our agricultural systems undeniably are under immense pressure. There are factors affecting this like climate change, population growth, and the drive for sustainability. At this rate, you will bear with me that we can't continue to produce systems that monitor our agricultural areas at the level of district or country. We need to begin to think at a bigger scale level. Effective responses require timely, accurate, and granular information about what is happening where across a huge area in agricultural systems, and this has traditionally been challenging to acquire at the necessary scale and frequency. However, intelligence at scale is critical, and AI actually offers a pathway. So today, I want to talk about how we scaled our AI work from the Open Buildings datasets. Is anyone here who's familiar with the Open Buildings dataset? Can you show by way of a hand? Okay, so I have a familiar crowd. And we scaled the efforts or the AI workflow behind this amazing dataset into developing an agricultural landscape dataset. As a key takeaway, I hope you will take, as most of us will start considering, that is if you're not already on board, to use AI as a powerful tool to scale our work. And also, I'd like for us to know that adaptation is a powerful tool, so you don't always have to start from scratch, because a lot of communities, a lot of organizations are providing solutions that can be adapted for unique cases. So let's dive in. Like I mentioned, we'll be looking at, I'll highlight very briefly the challenges in agricultural monitoring, and then we'll talk about Open Buildings as the starting point for our foundational data set we built. And then I'll share key takeaways, things that stood out for me about how this data set was built from the Open Buildings data set. And if time permits, we can dive briefly into some future prospects from a broader Google research view. Okay, so when you ask the question, why now? Next slide, please. No, back. Okay, so focusing on the question, why now? Just Africa, the agricultural context in Africa gives us so much as proof that this is the time to scale all the intelligence or all the solutions we build at a scale of beyond countries, like I said. So food security is at risk and yields have dropped. For example, in some countries, it's half what they used to have. And at the same time, there's a huge rapid growth, which requires about 70% increase of food production, ideally without extensive land conversion, because the land we're using is also being used for other use cases. These intersecting pressures, food security, low yields, and population growth create this need for better agricultural monitoring system. And so while innovations that are being done by amazing startups, including some who are here like microfinancing for equipment and insurance for rainy days, are moving towards that direction. Most of them are underpinned by a foundational monitoring data to scale their efforts. The big question here is, how can AI help improve agricultural outcomes? Next slide. Next slide. I actually forgot I'm not managing the slides. Okay, so there was an opportunity presented to us. You have to keep clicking for me. A survey was conducted by Startups for Sustainable Development in 2022, and it revealed the need for a fields boundary dataset, more broadly, an agricultural landscape dataset. So for context, this SFDS is a Google program that supports startups with cutting-edge technology, where we come in as a research team. They also provide connections for funding and provide expertise. And in 2022, when they organized this survey, they targeted startups that support smallholder farmers primarily in Africa. Again, why smallholder farmers? We can go on and on about this, but we know they manage a vast portion of cropland and are vital food producers. They supply about 1/3 of the world's food and are critical 80% of Africa's food. Also, they are essential for rural livelihoods when we consider rural livelihoods because they provide the main source of income for about 65% of Africa's workforce and those who face economic hardship. However, despite this critical role and this untapped source resources from their side, they are the ones who encounter significant productivity hurdles. They face barriers in accessing modern advancements and investment compared to larger operations. Again, this leads to yields that can be reduced up to 5 times lower in developing countries. And so this is where we believe we have an opportunity to make a difference. Okay. Okay. So the picture is sorry about that. So based on this opportunity, we decided to launch a pilot. The goal of the pilot was to evaluate an agricultural landscape dataset, firstly from the point of a field boundary dataset. And it was in 2 folds. The first part was for feasibility. Can we actually build such a system or such a dataset at a global scale? And for value, would such a dataset be a useful addition to the agricultural ecosystem? Given this goal, we decided to look into all the efforts we've been doing internally and externally. And we identified Google's open buildings as a starting point. The AI that was used to build this dataset was a good foundational point for us to build another model to predict field boundaries. So for starters, we will spend a few minutes diving into the Google Open Buildings dataset. That's right. I want to define what building maps data is. So it's a collection of information used to create maps, what you would see on Google Maps products, for example, and it shows the location and characteristics of buildings. Mostly they include spatial data, that is where the precise location is, and the shape. And they are collected from sources such as satellite imagery, which we use. Sometimes they also have attributes like heights and characteristics like type, but our team did not focus on these characteristics. And so if you see on like the image on the right, the left one is the satellite imagery, and then the right one with the red are the building maps data, or otherwise the buildings that we hoped to train an AI model to predict. Next slide. So the Open Buildings dataset is a project that was set up for AI for social good. It was motivated by another identified need within products internally at Google and also externally. If this picture successfully loads, which I hope it would, I'm showing a snapshot in a town, Vukuzenzele in South Africa, before the project. And we would see a vast number of missing communities in terms of buildings on this map. However, after the project, we were able to put these missing communities back on maps. Let's look at the technical aspects of this work. Next slide. Open Buildings dataset. No.
It's a high resolution image and it's not.
All the other images.
Yes. Oh,
Back. Okay, so we're having some technical issues. Thank you for bearing with us. Back to the Open Buildings dataset. I wanted to speak briefly about the technology behind the Open Buildings dataset because we adapted this technology to build the agricultural landscape dataset. So in building the Open Buildings dataset, our focus was on the Global South. It offered a unique challenge to us because in the Global South, there are buildings that are on water, for example, in Ghana and in Nigeria. There are ones that blend with the environment. So you'd have a building that looks exactly like the ground. And we have very dense structured buildings, even in urban areas. Another typical one is roof structures or grass structures that look like haystacks, but are actually buildings for some reserved communities. We wanted to make sure that the AI model we built was able to capture all these varieties. And for that reason, we had to build a data set from scratch. So we performed building detections using satellite images, high resolution satellite images available to us internally within Google. And then we train an AI segmentation model. If you could go back. Okay. And we train an AI segmentation model to be able to predict the presence or absence of buildings. I'm going to jump right onto the agricultural one since the slides are showing. Hopefully, I could follow from that. Okay. We launched the pilot in 2 phases, having successfully built the AI model for the Open Buildings dataset. And for the first phase, we focused on just Rwanda. Now, the key takeaway here is by doing the approach of a minimal viable product, which is not the actual product we want to share or make, we were able to get immediate feedback from few partners who agreed to work with us, provide feedback, use a data set for their tasks, provide feedback to us, and help us understand how better we can scale this method, which was the actual aim of the pilot. So Rwanda was the first, and we trained our model sometime 2 years ago successfully with a high IOU and a good enough recall that was appreciable by the startups that used this. So I'm showing you a peek at the data set. The differences in colors just denotes confidence. So the model overall is more confident, which is green, that it identifies field boundaries than not. Following that, next slide. We extended, after having received the feedback, positive feedback, of course, from our partners that this is good, this is useful for the ecosystem, and would like to see this in countries that are not only in Rwanda, because most of these startups, even though they were focusing on smallholder farmers, they start with one country and begin to move to other countries. So we have a list of countries, mostly in Africa, that they requested a data set for. And we decided, how about we go big? Get ambitious. Can we train a bigger model? At that time, we had field boundary label data set for India, Rwanda, UK, and Colombia. Mind you, the field structures in Rwanda, even just Rwanda and Kenya, are very varied. So in Rwanda, there are like 3 major types of fields. There's flat farm fields where you have the normal maize and sorghum and other plants. And there's marshlands, which are mostly close to water. And there's terraces, which are on hills. These are very difficult, even for the annotators we worked with, to label the images for training, to correctly tell that this is where the boundary starts and this is where the boundary ends. But in India, the fields are more organized, just like in UK. And so we had to come up with strategies to combine all these data sets together and train one model to be able to predict fields across areas. Again, if you notice, we had 4 countries only. available to us from our labels and from what we curated and collected. Mind you, labeling these data set could take about 30 minutes to 1 hour or 90 minutes. So it was a lot of substantial effort, and we had to optimize for what we can do with what we have in the time that was needed. And so what we did was, after training the model on these 4 data sets and observing a good enough performance for the prediction of classes of fields, tree crops, and ground classes, we scaled using a self-supervised method, which is a method in machine learning where you train on a large corpus of unlabeled data sets, but sometimes you can actually give a signal to the model you're training. We use a student-teacher method where the student is the new model we are training on a large corpus of unlabeled data sets, and then the teacher is the model that was actually trained on the 4 countries I am listing. And this allowed us to generalize the model very well. So what happens now? Do I go back? Because
Want to talk about that? Still have like 15 minutes.
okay. So is it okay if we go back or we continue from where we are now? If we continue, let's show my hands. Okay. Okay. Then I'm going to move to where I am at this point. I skipped. Actually, we missed a lot of fans. I'll slightly move if you can follow and then get a gist. Okay.
Maybe you start here a little.
No.
Oh, sorry, his Zoom crashed. This is fun. That's.
Okay, so I have an idea. If there's any question based on what I've said, I could take questions up to this point. Is there any question from the audience? I know it was hard to follow those slides, but if you got something that intrigued you or you thought I could shed more light on something I've said, please go for it. Yes, please. Could she get a mic?
Can you hear me?
Yes, loud and clear.
Thank you so much. It's amazing to see that, because this is a tool that is definitely needed here. Do you have a project to identify the type of crops? Because this is something that could be really useful as well. I mean, I understand all the technical difficulty you're facing just to delineate the crops, like the size of the crop. But yeah, I don't know if you're working on something that would be able to identify the type of crop.
So the answer to that is yes. The team, the broader Google Research or Google DeepMind team, has parallel efforts, okay? And one of these efforts is to move beyond just predicting where the field or agricultural landscape elements are to what is in them. So there is an effort. And one that has moved very forward is in India. So if it still works, I was supposed to show several QR codes and several links. There's an API for India data set. It has the field boundaries, but it also has beyond the field boundaries crops. And we're looking at moving beyond India, like we did from Rwanda to other countries. So yes, the answer is yes. Any other question in the meantime? Yes, go for it. Thank you.
Same microphone, different person. Thank you very much. I think that was fantastic. I just wonder how you plan to make this available. I was like, do you plan to make the data set available? Do you plan to expose the underlying model in some form of API? And could you maybe speak to ideas on how this could be usable, what the startup survey said, what kind of use cases people look into? Thank you.
Got it. So the data set, by that, do you mean the agricultural data set or open buildings? The agricultural. Okay, okay. So I'll answer the question briefly and then I'll continue. Thank you. So yes, the plan is to make this available. We're working with our Google DeepMind partners. Like I said, they already have an external API, agree with Google, And they are hosting on that API the same data set for India with other features like the colleague before you asked. And so our plan is to populate this new data set on that API and make it available. So if you visit the website, you'd receive a form to sign up, and then you'll be assisted as to how to use it. Yeah. Okay. Okay, so this takes us to the point of how we actually generated the agricultural landscape data set. We curated some labels. So again, we had to use high resolution imagery to be able to get the detail of accurate boundaries. And then we prepared labels with our annotators. We trained the AI model. We ran inference on a large scale, first for Rwanda for the first pilot, and then the second was on across Africa, Latin America, and India, I think. And then we exposed the data sets, the field boundaries as polygons in formats that are useful for our partners. Yeah, so we've seen this already. This is the first pilot phase where we trained the model on only Rwanda, and then we got feedback from our partners that this is good, this is a deal breaker. Most of them said they had to go onto the ground to manually label some fields, and this takes months before they are able to get feedback and then make decisions. So this was a deal breaker for them. And like I said, they would want this in other countries. And so we moved on to the second phase of the pilot, which we have seen as well as training on a larger area. And so for the ML strategies, I thought this was useful, and that's why I'm sharing them. Multi-label setup, and sometimes depending on the classes and depending on the data sets and depending on the combination you have, and traditionally, you should be able to throw all the data sets into one model and it works. But because of the very diverse nature of the types of fields in these countries, we had to do a multi-label training where we have a separate head per country and a separate head per class for each of the classes of interest. And if you're asking then how do we get the final one, we do an average of the 4 heads for fields, for example, to get a field class for any country anywhere. And on top of that, when we did a self-supervised method where we trained on a large corpus of unlabeled data sets, we were able to generalize this model to even predict fields here in Kenya where it didn't see any training or test data. Yes, so in the final data set, we're going to have labels of field boundaries, tree crop boundaries, and trees in Kenya, in Rwanda, and several countries in Africa. Next slide. Okay, so this was meant to give an illustration of the complexity of what we're doing. On the first left top corner, that is India. Like I said, the fields are well organized, well structured. I mean, if you were a human annotator, this is an easy task for you, although it could take some time. But once you begin to move to the others, which is on the right, the top one is a flat farm in Rwanda, as opposed to a flat farm in India. And the bottom one is the marshland on the left, and the other one is terraces. So you would bear with me that this proves some difficulty because we are going with a supervised learning method. And with a supervised learning method, you key in labels so that the machine learning model can learn to predict the labels correctly, which means if you give it wrong labels, it will definitely learn the wrong patterns and eventually give you a wrong model, which was a problem. So we had to do the labeling in several iterations to get the quality we want. And then again, applying several ML strategies, identifying a very good working model that could scale at this for these data sets, we managed to get a unique solution. Next slide. Okay. I wanted to speak to several key takeaways, but I picked this because sometimes we've mentioned the requirement of a high quality data set for ML training. Even if it's not with labels, you want to make sure it's representative and it makes sense and it actually captures the characteristics that you want to predict. But outside the model training, you need to also spend time with an extensive evaluation, and that's what we did here. For the first pilot, when we did an evaluation, we realized that these are the 4 categories of issues the model always faces. And so it's either overly segmented or under-segmented, or some classes are missing because they are not well represented. In the first data set, marshland and terraces were not well represented. And so for the second one, when we had more labels, the model was able to do better by identifying them. Once you do this performance evaluation and you build such a foundational technology, you want to make sure your users, the partners or the startups or the companies working with you are well aware of its limitations, and that was what we were going for. Next slide. Okay, so in summary, the highlights for me are this. This should give you the link to the API. You could try it, and I hope it works. Our MVP approach, which is the minimal viable product approach, was crucial for the scaling agricultural landscape data sets. It allowed us to scale incrementally for this complex tasks by incorporating feedback effectively at every stage whilst working with our partners or startups. So what really streamlined this effort was focusing on these key steps. The first is investing deeply in a data set that gave us the characteristics that we wanted to capture in our final big data set at the scale we wanted. We also invested deeply in understanding the limitations of the data set. One thing that stood out for me, for example, no matter how quality or high your satellite resolution imagery is, it is almost impossible to identify where the boundaries are. So there are certain farming systems among communities in Africa where they could use things like woods or sticks or stones to delineate farms, right? And you don't expect to capture that. So these things stood out for us, and we had to find a way to model several interventions in our data set. Okay, the second one was developing a model efficiently. Like I said, adaptation is a very powerful tool in AI. A lot of people are making efforts, groundbreaking research, creating new models, and developing solutions, some of which are open source, some of which are not. So you don't always have to start from scratch if you want to consider this line. Also, defining what clear metrics and acceptance criteria looks like before a pilot helps. One thing that worked here was it's always a struggle if you have a high bar for yourself. Like, you want to make sure the fields are so good and amazing and our people will be well by then. But sometimes, maybe as they are, what you have is already useful. And so by defining these acceptance criteria and metrics, we were able to connect with our partners and say, hey, at this level, do you think this is useful for you? Would it be able to satisfy your needs? And whilst we did that and whilst we got feedback, we were able to improve upon the model. And finally, committing through performance evaluations, like I said, which gives us insights and areas that we could improve. Yes, so this structured process allowed us to build an ALU data set, and we're working, this is the one in India. A similar one has been created across Africa, several countries in Africa, Latin America. We're working on ingesting it on this API and making it available to interested parties. So ALU is agricultural landscape understanding. Can you go back a few slides? Let's see if this will work. Okay. Here it comes. Okay, so when we talk about agricultural landscape understanding, it starts from full agricultural landscape understanding, which is what I tried to capture with this image here. And you're basically focusing on a snapshot of an agricultural landscape, and you want to capture a complete inventory of where everything is and what is in everything you find. So you could have different types of plants, different types of farm fields, and other characteristics of the environment, which are not necessarily for farming, but it helps you understand how these lands are being used. So that's agricultural landscape understanding. The full one goes beyond the field boundaries that we do to actually predict crops, like our colleague asked earlier. But our focus was to start with the boundaries because these define where things are, and it distinguishes types of crops and types of characteristics from each other. So on its own, just the landscape understanding, which includes the boundaries, is a foundational capability for a lot of startups and a lot of users in the agri-space ecosystem. Okay, we can move back. I'm wrapping up here. Thank you for bearing with me. Next slide. Okay, I said I should mention that now that we have succeeded in doing this, and we are working, of course, to make sure it's available to users. Next slide, please. What is the next thing from here? So Aisha introduced with all the amazing work we've been doing, mostly focused on remote sensing. And for us, the next big thing is, okay, so there's a trend here. We never get satisfied, okay? And that's because the need to scale and to produce efficient resources is real here. So we have been able to identify these different use cases like agriculture and open buildings, wildfires, like she mentioned. If for every one of these issues, including the ones we're here to identify and solve, we're going to get a new model, that could get intensive. So for us, the other thing that parallel efforts ongoing within the Google research team is, can we find a one-size-fits-all? Can we build a big foundational model focused on remote sensing tasks that captures most of these things in the background in an embedded space? And then on top of this, make sure we provide opportunity for the entire public to build unique solutions on top of that. Next slide. One thing that comes to mind is Gemini. As you may know, it's a general purpose multimodal foundational model. So it accepts images, text, videos, and is doing a lot of analysis, has proven to be very useful. And so for us, the next one, next slide. Yes, for us, the next thing is, can we use Gemini in Google Earth? Next slide. This is an ongoing research where we are analyzing how useful it will be for Google Earth to have access to an AI tool like Gemini. If this proves useful, we're going to scale this effort beyond our internal tools like Gemini into providing foundational models and make sure they are useful for the public. And that is the next direction for us. Okay, so I'd like to end the talk here. Briefly, I wanted to shed light on the need for scaling the intelligence systems we build, and one of the ways is AI. As a key takeaway, like I've mentioned, we don't always have to start from scratch. You can always adapt systems that already exist, and we need to make sure we work together as an ecosystem to fight this issue. Thank you. Please reach out to us.
An extra round of applause for her. She managed through the small crash hiccup there, but I think, thank you all for hanging in there. The work that her and her team have been leading is why you can see buildings on when you open maps. And this is the power of being in Africa, is we look at the problem space and we're able to say, hey, we are not represented, but we all work in the same company. How do we make sure that we are represented? And this is that was the beginning of the AI for satellite imagery work, and that came with the open buildings data set. This is all available. It was also recently released 2 more iterations of that data set. One is temporal buildings data set, and that you can see like the evolution of Nairobi, which has been incredible over the past decade or so in terms of how much has been built up, but you can do it for many places across the world, and now including building heights. So we're seeing many use cases from disaster response to census to understanding where populations are for even vaccines using that data set. But at the core, she talked about foundation models and the key machine learning technology that enabled her to take that use case and then start to explore use cases that are also as important for the ecosystem on the field boundaries work. So a huge round of applause for Abigail and team. We have one of our colleagues, Tavanga, I don't know where he is in the room, just in case you spot him. He's our product manager, huge ag tech in Africa background. Feel free to reach out to him as well. He'll be looking at different use cases. And then we are happy to entertain any questions for the last couple of minutes here. Bush, right her down. There's one there, yes.
Okay, thank you very much. This is quite interesting and really educative. My question is transformation of agriculture or agri-food system is also has to do with issues of soil health. And having seen the content of your presentation, I begin to ask myself, is there any future plan for your organization to look into soil mapping? Because getting the boundaries, yes, okay, but we need to see the content. I mean, what the health and the structure of the soil is in those boundaries to sustain the agri-food system. Thank you.
Yeah, so thank you for your question. To answer your question, there are a lot of parallel efforts within Google. It's by various teams, and beyond what we presented today, which was just the agricultural landscape understanding, there is a strong ongoing effort for the full agricultural landscape understanding. So it goes beyond the cropping to soil, predicting soil moisture, predicting certain bits of the soil that could help further the ecosystem in understanding the agricultural landscape. So the answer is yes. As to whether, so this is the thing about research I didn't mention. When we started with the Rwanda pilot, we estimated 6 months. It took us over a year because it was almost impossible to force the AI model to learn the features we wanted to learn. And so sometimes you start on a trajectory, for example, understanding or predicting soil moisture, and then you realize the tools that are existent are not good enough or are not capable enough. And so sometimes we could put a pause and go back to it, but it is always on our radar. Like we have a long list of projects we're always aiming for and then prioritizing based on accessibility to tools and based on what the partners and our customers and the organizations we're in touch with ask. So yes, it's part.
Maybe one more question?
I'm wondering that I would love to see if you take product development requests. One thing I'm looking at when I'm seeing this is the ability of AI and technology to bridge between, like typically farmers don't speak finance, finance doesn't speak farmer, and no one speaks conservation. And with changing sustainability legislation and regulation, and even for a country like Kenya, massive exporter of coffee, tea, can we use tools such as this to unlock climate, nature investment, impact investment, and de-risk and reduce the debt burden in adaptation and getting more money into the hands of farmers who are at the forefront of the effects of climate change? Thank you.
Brilliant question. The questions are really why we're here. This is exciting, right? So you talked about soil health. They're talking about how do we make this the right investments using more data and evidence for that. So that is exactly what our aim is to do. This is not, it's not for us to make up. These are driven because of you all, because of the challenges of the ecosystem. None of this work is done alone or in a silo in order to have the right scale of impact. So bringing those use cases around the investment part, let's follow up. Tawanga's here, we can have some discussion, but it's exactly those exciting use cases where we can see the potential impact for this work. Thank you.
Thank you so much, Abigail and Aisha, for actually introducing us to very useful use cases of AI and generative AI. So before we move ahead, let's just play a very, very quick game, which is called Future or Fiction. Can you please raise your hands, just one hand, and keep it raised if you feel that it could be a future or is a future, and keep it down if you feel that if it is a fiction. Can we just raise one of our hands, please, to start with? So I'll just speak. There's an AI that can spot a nutrient deficiency in maize using a farmer's phone photo. Is it a future or a fiction? Great. I think we are already doing it. The next is a model just beat human plant breeders in predicting high-yielding weed crosses. It could be a future. Great. So all these hands, probably, I believe that you all are supporters of AI. Thank you so much for this. We'll be moving to our next session, which is on intersection of cutting-edge technology and real-world impact. Generative AI for advisory services. As generative AI becomes more powerful and accessible, we have actually seen in our previous presentation, the key question is, how can we effectively leverage it to enhance the agricultural advisory system? So let's just hear from our experts, Andrea and Satish from Summit and Jao from IFPRI. I welcome you all, please.
Okay, so it's me, right? So hello everyone, my name is Andrea Galesal. I work for Summit. I've been working in digital innovation for a while now. And our talk, along with Satish, my colleague, that will talk about the use cases, concrete use cases that we have. We're going to talk about hyper-localizing. Hyper-localizing meaning we have seen a lot of things that we can do with AI at the model level, at the science level, even within CG. We have a lot of things going on that end. And then on the other hand, we have farmers' realities, right? We have the very local contexts, we have the very specific needs. And this talk is about how we explore and transit that path from the high-level models to the local realities. Can we go to the next one, please? So why hyper-localization matters? This is just two very recent insights, but this is nothing new. We're not talking about anything that we've not heard before. Basically, digital innovation has been there for years, but we require customization to local contexts to understand capacities and needs and specific cropping systems as well. That's one thing. The other thing we have from these recent research is main barrier is low trust and poor localization. So the combination between low trust and poor localization, it's actually hindering adoption, hindering iteration as well, and hindering customization. Let's see if this works. Can we go to the next one, please? So another one, why does it matter? You need to continue because it has animations. So on the right, as I was saying, we have a lot of agronomic models, climate analytics, soil analysis, crop science, and what we do, science-based innovations. On the other side, next one, please, we have hyperlocal realities, decision-making needs, we have availability, we have accessibility. We were listening yesterday about that. We have the risks at the local level. We have the risks at the livelihood. We have the risks at the home. How we have done this before is through iteration, iterative use cases, co-creation, participatory research. I'm not saying here that we've not done anything to cross that bridge, right? We've been trying hard. However, can you go to the next one? We have still a missing middle in between. And this comes when we're trying to take these at scale, right? If we're going to take these digital innovations at scale, we lose the understanding of the hyperlocal reality. We lose the connection, thank you. We lose the connection with the actual needs, and we actually lose sight on what is really needed. And we end up designing, developing, deploying, pushing things that are not used. So based on that, this is just to group things. Science on the one hand, farmers on the other. We talk a lot about that. We talk a lot about we do science, you are the farmers, where are the farmers? We've been listening, where are the farmers in these meetings? It's not only about where are the farmers, it's also about what's the missing middle, who's in between, who should we talk to, right? So since we're talking about AI here, we have been working on how can AI actually help us bridge those two worlds, let's say. So we have some ideas here. We're starting to explore this, so more than happy to take all your comments and ideas. First thing is local knowledge amplification. So this means, for instance, think about we have extension agents in the field
those extension agents are doing their field reports, visiting farmers, taking pictures. And we have those field reports sitting somewhere. But we also have farmers' questions through a chatbot that we have sitting somewhere else. But we also have extension reports from local governments. What do we do with that? With AI, we can actually augment, enhance, and integrate those fragmented local, very local sources to actually better inform advisory services. That's me. The second way, RAG. Can I just ask a question? Do you know what we're talking about? Can you raise your hand if you know what we're talking about when we say RAG? Okay. So RAG stands for Retrieval Augmented Generation. And it's basically using content, local content, specific content, if we're talking about local here, but specific content that you can put on top of a traditional LLM to make it more specific, to reduce the options that the model has to give you answers. So this is a tool that we have been using, and Satish is going to talk about that, to actually hyper-localize LLMs like ChatGPT. Because what happens if we've done some workshops and trials with farmers with ChatGPT. So we go with ChatGPT to the farmers and we ask them to use it. And then we ask, how useful is this? And they would say, yes, it is useful. We don't trust it. Would you act upon it? Maybe not. It's real. Yes, it is. It sounds like something real, but I would not act upon it. And also, it's very high level. It's not talking about my field. It's not talking about my cropping system. It's not talking about what I do as the extension agent does or as my neighbor does. So RAG is helping us on that. So bear with us. Satish is going to talk about that. The next one, multilingual and dialect adaptation, sorry. So this is about going to local languages as well. We have English, we have Spanish, Hindi, but we're talking about Swahili even, but we're talking about local languages. And it would be very nice to have a conversation with our Google colleagues to try to understand how far are we going in terms of languages, local languages in Africa, because we're very ready to use that to translate all these hyper-localization processes. Because at the end of the workflow, you have something in English that you really want to translate into the local language. And it's not only translating from language to language, it's also translating from type of content. So think about a research paper translated into a recommendation. That's another whole thing, right? The next one is user-based personalization. I don't know if there are agronomists in the room, but we've done farmer typologies for a while. I'm not an agronomist because I'm really one of them. But yeah, we've read about farmer typologies for a while, or also the domain recommendation domains. We need to move out of that, and AI can actually help by targeting profiles per farmer. So this is not about clustering, this is about farmers, each of them with their own production systems. Corpus validation, curation as well. So actually, if you already gather a local corpus of content, AI can actually help identify where you have the gaps. Where do we need to collect ground truth data? Where are we missing information? Another one, and this I'm gonna do these last three, is basically how AI should be in the loop. Sorry, humans should be in the AI loop. What I mean by that is we have the extension agents in the field, we have the farmers in the field, we have local institutions in the field who have a lot of content, the content that I was talking about before, but many other things. They can also validate whatever our systems, AI systems are doing, so they can create healthy feedback loops that are constantly improving our ways of providing advisories. So again, if you have any other idea, more than welcome. So based on this, we have thought, okay, what can we do to kind of organize ideas around the framework to make sure that we can actually cross that bridge between, remember, science and farmers with AI. So we did this model where we have on one side features meaning all the things that we can technically build
to reach the farmer. So AI chatbot is one of them. Model marketplace. So as we've seen, we have several models for weather, several models for crops, for fertilization, pest and disease alerts. So integrating all those models is also something we are calling a future of agriculture. Crowdsourcing data. So we have identified that, as I said, we have a lot of missing information. We have a lot of gaps. So there is a need of a feature to collect data, but collect data selectively based on what AI and models have told us. Push alerts, we know that. Step-by-step guides, WhatsApp training courses, benchmarking. Benchmarking, let me tell you a story. Benchmarking in Mexico, where I'm based, we have been working with this for a while. We collect data from the farmers in terms of yield, their activities, what they do, and they're very interested in knowing where are they in comparison to the neighbor. How is your yield compared to your neighbors? And then you can also want to see what did that neighbor do. So that's what we call benchmarking. And surprisingly, they trust that a lot more than anything else. Technical assistance 1-on-1. Then on the other side of the diagram, the other dimension is localization strategies. As I said, we're trying to cross the bridge through localization strategies. Which are they? Channels. So we're not only talking about WhatsApp, we're talking about audio podcast, IVR, SMS. Not everyone knows how to read. Not everyone knows that language. Not everyone has internet connectivity. So channel is one of our localization strategies. RAG, I already mentioned. Community content, I already mentioned. Prompt engineering, also another option to make LLMs a bit more localized. Language, I already mentioned. Text to image generator. Satish is also going to talk about that. Local semantics, let me stop there. When it comes to agronomy, everyone is going to say agronomy is very relative. It's relative to the context, it's relative to the cropping system, but it's also relative to the language. So a thing that you call somehow here might not be the same in the next region, the next town. So if you're going to work with LLM, if you're going to work with generative AI, you need to take into account local semantics, meaning are you calling things in agronomy in this particular place? And the last dimension is topics. So we are already considering some of the topics that we could work with. Pests and diseases, climate adaptation, grain quality, weather patterns are some of them. So let me give you some ideas to this. What comes out of these? That's my point. So this means we can have a RAG as a localization strategy for regenerative agriculture as the topic in Kenya for an AI chatbot. That could be a use case. It's right here in WhatsApp. Another one, seasonal forecast at the municipality level that is being done by models. We get the models already. We have the seasonal forecast for the next 3 months per region in Mexico. But AI reading is helping us to generate maps for the particular plot. That's another one. Crowdsourcing data via audio, I already talked about that. This one, we have been doing pest and disease monitoring for wheat rusts in Africa for at least 7 years. We have the models, we have the partnerships, we have the supercomputing powers that we have everything, we have the insights. But there is a need of having a human doing the interpretation of those models to generate reports per month, per sub-region, per country. And that was not being done. So we do a RAG. We take all the reports that have been done in the past to tell the model, this is the way you should interpret, and we're generating those automatically. So before we couldn't address more than 10 countries per month, and now we can do 40, for instance. One more example here. We have in the AI human in the loop relationship, we have extension agents in the field with the networks ready to validate and to be part of the process of validating the answers of the chatbots that we have.
And those answers and those validations are coming in again into the LLM and are making us be sure that we have validated responses at the local level. Okay, so who do we work with? Yes, we work with farmers. I've been clear about that, but we are not aiming to work with them only. We're willing to work with the in-between. We've heard that today as well. So program sponsors, data knowledge actors, market actors, farmer support services, smallholder farmers. So how do we work on this? We select use cases, yes. We want to go to the scale through use cases that can be scaled. So the way we work with each use case is we do the data input analysis, we do the AI or any model analysis, then we support the use cases through that. We do the hyper-localization, and we iterate with the user experience. That's the way we operate in each of the use cases that you're going to see. So finally, what's our value proposition? Agri-Tutor is not a chatbot. It's a highly tailored advice to stakeholders. It allows that, but it's a platform that you can plug in, plug out, whatever model you have, whatever service you have, in order to reach and cross the bridge that I was talking about. So we have a common infrastructure enhanced by AI that lowers the barrier to entry, encouraging the support of use cases that are not currently being attended. In that cube that you saw, we already have some cubes filled in, some others are not, and we're actually and actively looking for those use cases. What Agri-Tutor is not, it's not restricted to a fixed scope or delivered as a specific product. So it's not an AI chatbot only. It could include it. It could include chat services, dashboards, training courses, many other things. We're open to that. But this is an open infrastructure, an open framework that can actually allow us to plug in, as I said, and plug out whatever is already available at the local context to actually make that content get and reach the farmer. So I'll stop there. I'll give the word to my colleague Satish, who's going to talk about the 3 main use cases that we have at the moment. Thank you.
Thanks, Andrea. Good morning, everyone. So I just kind of want to start from where Sandra, our chief scientist, kind of morning left. She was talking about a new city with all infrastructure getting built up, right? So I'll tell where Agri-Tutor in that city. In that city, Agri-Tutor is one apartment complex where you'll have multiple use cases, everybody's own flats in that building, that apartment with common infrastructure related to that particular apartment and things. So with that context, I would like to start. So, and I think Andrea has kind of heavily lifted most of the framework related to Agri-Tutor, and I'll kind of explain like few unique use cases that we have got in the Agri-Tutor framework, which is kind of operating across all the 3 regions that we work, which is Asia, Sub-Saharan Africa, and Latin America as well. So the first one is localized RAG for farmers. Though it is one single use case, it actually caters to 3 different regions. Okay, and all 3 different regions, it's 3 different RAG models, RAGs that's been kind of implemented. Okay, which means like we have localized compendiums, localized knowledge corpus, localized thing suiting to those specific regions. And here what we are doing is we're using RAG to kind of generate responses to farmer queries in audio, okay, and through WhatsApp as the delivery mechanism. So farmers use WhatsApp to ask questions in their local language, and the response comes back generated through AI in the local language as audio. And in some cases, for example, in Bihar in India, where extension services available for that particular specific region and the project, where farmers are not satisfied with the responses from the AI, they could say, I want to know more, or like more, or ask questions. So then what happens is the same query that was generated by AI gets forwarded to the WhatsApp of the local extension agent of that particular district or that particular block, and then the local AI, the local human extension service staff actually responds to that. So that's where we are bringing like human in the loop, okay, apart from the AI responses that we give. And in Latin America, for Mexico, it's a pure like AI, just direct AI thing, and like we want to kind of integrate the human intervention there as well. So we have three use cases where we have kind of tested, and we are kind of planning to scale up or scaling up in the next coming season. So we can see the crop coverage in India. It's maize and rice, and we're kind of trying to add mung bean and potato and sorghum as well. And in Mexico, it's maize, wheat, barley, and sorghum are getting added soon. And in Kenya, we did a pilot with some 150 farmers, kind of in Swahili language, testing the chatbot as well. And it had like maize, Irish potato, French beans, and green gram. So we kind of looking for partners who could scale that as well. So that is there. And this is the end-to-end rack process. The way we operate is like we kind of first scope out the geography, we scope out the farmers' QA questions, the crop questions, and then we kind of find, scrap the web and scrap for knowledge resources, knowledge corpus, not within CG, but also outside CG. One important thing that we kind of understood is CG content alone doesn't help. We also need other content coming from the national partners and other advisory service, which we get validated through our human, in-person experts, and then we kind of pass it on to a RAD pipeline, which kind of generates these responses. So the next thing, what we want to do, this is just a initial pilots where we want to kind of expand it to more crops, more geographics, more countries, and partnerships are welcome if anybody wants to kind of implement the local in your local context. So that's what we have done in terms of how we have leveraged RAG for farmer query responses in local languages in local contexts. The next thing is something very interesting, and this is, I think many of you might have kind of understood. We have been talking about data collection, important clouds, data collection from morning, right? Structured data collection, and data collection is expensive. I think we need to acknowledge that, and we know that data collection is expensive, especially data collection coming from farmers' field. But you can't ask a farmer to kind of start getting into an app or any mode to kind of type data and kind of send it every day, right? That's not possible. So what we were thinking is, we were kind of wondering with the LLMs and other things coming up, why don't we kind of use AI to kind of record the Q&As? In terms of the questions that for which we need responses from the farmers through a phone call. Okay, so instead of an extension worker going to the field and kind of doing it, we thought we could kind of have a phone call to the farmer, and farmer picks up the phone and responds, and that gets recorded through IVRS thing, and that we use NER and NEDs, okay, to kind of extract data from that. And from the audio, what happens is, maybe I should show them. Yeah. So from the audio response that we get, the audio gets decoded and encoded, encoded and decoded, and then we kind of extract data into a table, okay, like which we can use it for any systematic thing, okay. And this, again, we just piloted in Bihar, where we have a project, and we are going to run a big survey with about 300 respondents this week. It's going to kick in, and the same thing we are expanding to other project use cases within Summit at this point of time, where we have Spanish, Odia in India, Nepali in Nepal, and Bangla and for Bangladesh. And we're also trying for Chichewa. I think that's where Google's support might be helpful, especially in terms of Chichewa, which is more in terms of the Chinyanja triangle of Malawi, intersection of Malawi, Zambia, and Tanzania. So I think that's a language that we really need support for. And this is where we kind of leverage AI for data collection, and that data comes in and sits in the database as a structured format. Now, moving to the third one. And I think hope you all got what when Andrea mentioned, like, this is not a model creation platform. We are not creating models, we're not working on models, but we kind of want to use the existing models and how we could take that to the farmers. I think that's one of the key things that we're doing. And this is wheat rust advisory generation has been happening for some time as part of a big project. Okay, early warning systems where several universities are working together to kind of put up a surveillance system in terms of data collecting on wheat rust disease, okay, which is very key. And they're spending a lot of time in terms of looking at the data, analyzing that, and generating advisories out of that, right? So what we want to do here is to kind of based on the advices that has been historic advices that we got, and also kind of we want to train the model, okay, to kind of generate the advisories automatically, and also create infographic based advisories, because these advisories which we create are actually given to the national and subnational partners. It's not directly reaching the partners, because the national partners consume that and they kind of translate back into the farmers field. So in that sense, like we want AI to be leveraged to summarize and generate advisories from the models that's coming out, and also convert that into automatically convert that into infographic based advisory things, which could be readily used by the national partners and the subnational partners to kind of disseminate, and other partners to kind of disseminate. So this is, we just completed the ideation. We're just going to start the development process. I think next 1 month or 2 months we will be having. And this project already reaches to more than 100,000 farmers in Ethiopia and Nepal and Bangladesh. So I think this has huge potential once we kind of start scaling up for other countries as well. Yeah, and eventually our idea is also taking the advisory to the farmer level. Okay, but that could be later stage. But at this point of time, it will be only for national partners and other subnational partners there. Yeah, so as I mentioned, I'm not going to talk about all the use cases that we are working on, but this is a glance of some of the use cases in different thematic areas that we are working on and its status. For example, weather advisories, where what we have done is, again, we have taken the models which has been kind of predicting the forecasts and nowcasts for weather in Mexico. What we have done is we have taken those models and we are using AI to kind of generate maps and kind of give advisories, push advisories to farmers through WhatsApp. Okay, so a visual map is generated and farmers are using that to kind of interpret. So that's one thing. And we have done the pilot with few farmers, and now we are ready to scale from this season. I think probably next week or so. And then market intelligence is something which we are trying to work with government of Maharashtra, where we want to kind of bring in different multi-layered data sets and kind of to predict, help farmers to kind of understand which window of sowing will help them to kind of get better prices in terms of eventually based on the historic market conditions and what could be the future conditions as well. So that's something which is initial ideation and development phase. Soil health, we have done a pilot and kind of sustainable intensification in Malawi, where we kind of using RAG for extension workers, and that's in English. I mean, the challenge there again, I mean, if we have Chichewa or other languages, then it would be easier for us to kind of take it to farmers. But the constraint there is language, so that's why we have kind of kept it in English, and that's only reaching out to extension staff. So there's a POC with the extension stuff, but we need to work out in a model to scale up to farmers. And seed dealer map, this is part of a bigger thing that we're trying to work on, the seed systems, visualizing the seed systems. So one thing is like we want to use NER and name entity registration or name entity disaggregation methods to kind of map the seed dealers in the region and to kind of put them on a catalog and kind of tell farmers like where they could access which kind of seeds and everything. So that's a pilot ideation that we are having with the seed systems team. And another thing is Agri-Food Academy is a platform that was an output from the digital innovation initiative of the previous year of DTA, right? And so in that, what we are trying to kind of do is we have WhatsApp-based courses to farmers, okay, where farmers could access any courses and kind of learn micro modules, bite-sized modules in their local language on WhatsApp on just clicks. But there also we have introduced RAG and GenAI, where farmers could ask a question and the response would come to them immediately, and that's through WhatsApp. So this is kind of some of the use cases that we are working on. And yeah, that's it. Thank you.
Yeah, that's happening. So, yeah. Okay, so yeah, thanks, Andrea and Satish. So any question from the, okay, yeah, please go on.
So I have a question to Andrea. In the aggregative value proposition, it was mentioned digital maturity. So can you please elaborate upon it?
Sorry?
In aggregative value proposition, it was mentioned about digital maturity.
Digital maturity.
Yeah, so what is that? Nice, thank you.
Is it working? Oh, okay. Yeah, so let me go back quickly. The main idea here is we need to have criteria to select where, why, and how. Because hyperlocalizing entails understanding. So how to understand is we're talking about complex contexts, right? We're not talking, this is not a linear process. So assessing what the context is about entails a series of things. So in this case, digital maturity means, for instance, if we're talking about WhatsApp, we're investing a lot on WhatsApp chatbots, right? But if you don't have connectivity at the level of WhatsApp requirements, why would you do it, right? Maybe you start from scratch, but by saying, okay, we'll do AI at the headquarters and then we push through another channel, maybe IVR. So digital maturity entails the digital ecosystem assessment to understand what would be able to be scaled or not. Any other question? Do we have time? Please.
I'm just curious. When you mentioned you are using local insights, local knowledge. So can you give me an example of how you utilize a local knowledge and how successful is it? And also, if in case of some people cannot access WhatsApp, so how can you deal with that?
Yeah, so I may say what is local insights. So I think I gave a couple of examples. For example, we have field visit forms. This is extension agents going to the field, filling in a form, taking a picture, writing the opinion about how the crop is doing. That's a very hyper-local insight that at the end, when you collect several amounts of field visit forms, you can actually do something with it to improve your recommendation at the region level, for instance. And how we use that, maybe Satish can talk about.
Yeah, in terms of, I think your question was on terms of connectivity as an issue, right? Yeah, I mean, that's a major challenge. And one of the ways that we are trying to kind of approach that is in terms of, for example, in the same Chinyanja triangle where we are working, okay, what we are now trying to do is like we are providing the regulator AI RAG framework to the community radio stations there, whereby farmers could ask a question to the community radio station and recorded it through an IVRS file. And community radio station, somebody there, like they translate back into English and ask the question, and then translate back and then broadcast as a program, okay, so that it's get disseminated through all the farmers. It's not just for the person who has asked. So we are trying to kind of explore community radio station, community radio as a channel. In addition to that, like for other things, we do have IVRS, but IVRS quick feedback is not there. So we kind of leave it as a recorded thing, and the farmer might get their response maybe within 15 minutes or 20 minutes time gap. Then there would a call which goes back to the farmer. Then the farmer would listen to the response. So there's a time delay in that. But so that's what I mean. We need to be inclusive, but we also need to kind of be aware like the constraints that's there. So we need to kind of find out. That's what we say hyper localized. So based on the context, based on the community, we find how we could take the existing solutions to the farmers. Thank you.
Thank you. Okay, yeah. Thank you, Andrea, Satish. Can I invite AIEP team to the front? So while we are setting up for the next session, actually, I also have a couple of slides to share.
It's part of the script.
Sorry?
It's part of the script.
Yeah. Okay, you're today. Okay, good. Just speaking of Gen AI, so there is another project on Gen AI, specifically called Gen AI for Agriculture, in short Gaia. And I know there is another Gaia project somewhere here, so apologies for that. We are using same acronym. So this project launched last year, and we are on the second phase of extending it. AI team, you can come to the front and sit in the center. I think you have a big team coming up with it. Okay, good. So this project has run for 1 year. We are looking at how we can effectively use Gen AI tools in agriculture, especially for advisory services. And we did research across the centers and also with partners, and we have some lessons learned I wanted to share quickly. The first thing we did for Gaia project was to curate domain-specific knowledge, especially from CGIAR. And so if you are part of CGIAR, all of your research papers and everything, report and everything goes to the knowledge repository called CG Space, where Alan here is helping to managing and supporting the value of research. So we kind of scraped everything as we can, as much as we can, the open access and shareable information. And then we created AI LLM ready data set. We posted this, we published this data set to Hugging Face February last year. And by now, there are about 2,500 downloads have been happening. So this data set, if you're kind of developing any RAG or LLM application focusing on agriculture, please take a look at this data set. This has an enormous wealth of data from CGIAR. We also try to develop a RAG framework as Satish and Andrea presented. It was actually quite difficult. I mean, there was a certain value of it, but we just found, maybe it's not the best thing CGIAR can contribute. But I mean, there was certainly a big value for that. But the LLM landscape technology is so quickly changing. We also saw maybe there are some new technology coming up, new standard coming up, and we just follow the wave. We did also our own usual research in India, and a lot of farmers actually had really high expectation what they want to get out from Gen AI chatbot. Local language, multimodal, offline tool, and they also favored WhatsApp or Telegram, just chatbot inside of those apps they already have rather than standalone app, which makes sense. The data governance and content governance for AI is really sticky issue, and we found it really difficult to address it. We'll continue work on it for next phase, because when you mix different licensing, differently licensed content all together into this AI training data set, it's really difficult to see what data goes where and how they are used. So we will spend lots of time on figuring that out, and we'll continue to look at how we can effectively do that, especially with our partner content. Evaluation framework is really important, but it's really difficult to also implement evaluation. There's so much you can do with our human experts. So actually, we found it more useful to actually implement evaluation framework also automated using LLM. So there are also many innovations going on. And the lastly, gender sensitive design, it was really interesting to look at, but very critical, another very hard challenge. I don't know if Niyati is in the room. So we did some website kind of assessment that we kind of provoked a different kind of chatbot, a very wrong questions, and then chatbot actually responded pretty well. I mean, that's not a good question. You should look at gender aspect this way and that. But it was so kind of local specific. Like for example, my colleague sitting in Washington, the gender expert, look at the chatbot response. Actually, she didn't find anything wrong. But when we shared that with gender expert in India, where this study, the content of the study was about, actually she found a lot of issues that no human expert would use that kind of language, but actually chatbot are just putting up. So there are lots of issues around it. Anyway, so this is, as a researcher, this is not just tool, not just technology. We just really need to be careful about what we can do and how we can use this on the real life with some of the farmers. So that was my quick presentation to fill the gap. I don't know what's happening with my laptop. Okay, so my Zoom crashed again. Okay, good. So I will try again, and maybe Christian, you can come and set up the next stage. Oh yeah.
Thank you, Jaru. Thank you, the DTO team. Don't you just love how the DTA teams mix the technical into something very relatable? I just love it. I love it. My name is Karen. I work for the DTA.
I'm so grateful for everyone who's here, who's stayed with us up to this point, both physical and online. Thank you so much for joining us. And so it's my responsibility to introduce the next session. So we're talking about designing advisory services for small-scale producers. And the agriculture information exchange platform that JAWU has been calling up, which is the AIEP, is an initiative aimed at bridging the information access gap for low literacy, low digital skilled smallhold farmers, who are the people we are trying to get this science out to. And by developing open source, AI-powered and gender-sensitive digital advisory tools. So 4 cohorts, that is Digital Green, that's one, the Hat with Dalberg, IRI with CIMIT, and Viamo have collaborated to co-design and test these AI-powered minimum viable products. Yeah, and this has been happening in Bihar, in India, as well as in Kenya. And they are integrating local language interfaces, personalized advisory content, and omni-channel delivery platforms such as WhatsApp, IVR, and SMS. And in this session, the AIEP team will present their key achievements. They will share their learnings from co-creation and end-user testing that they've done. And they'll also outline opportunities for scaling. Yeah, this modular and interoperable architecture tool, and this will improve the livelihoods of undeserved farming communities. And so with this, I want to welcome the team. The team will be moderated by Kirti Pandey, who is part of Open AgriNet. Welcome. Kirti. And the other team members are Christian Marks from GIZ. We also have Nerea Okanga, Digital Green. As I call you, please welcome here. There's Nancy Winder, and if I butcher your name, please excuse me. And she's from Viamo. We also have Mayank Jain from Sumat. We have Prakashan Chelatan from IRI. We have Joe Monene from Opportunity International, and we have Melvin Mutai from Safaricom. You are all welcome here. Karibu sana, as we say in Nairobi, you're all welcome here. Yes.
Hello, everyone. We are here to speak about the Agriculture Information Exchange Platform. I'm Kirti from Open AgriNet. We met in the morning, but I've also been part of the AIEP project. So this is a project funded by Gates Foundation and commissioned by Fair Forward at GIZ. And the idea behind the project is to bridge the information access gap for low literacy, low digital skills smallholder farmers through developing open source and AI-powered gender-sensitive tools. And as a part of the project, we have had 5 cohorts, which include 30+ organizations, which collaborated to build and design AI-powered minimum viable products in Bihar, in India, and Kenya. All of our cohorts leverage LLMs and provide personalized and advisory through multiple channels. So the idea behind the session is to share learnings, and we have with us here our partners Clear Global and Christian Mertz from GIZ, who leads the project. And I'll now hand over to Christian, who will talk in more detail about the project.
Yeah, thank you, Kirti, and welcome again from my side. Just to correct a few announcements, we actually have not only 4, but 5 cohorts. Recently, Opportunity International and DigiFarm has joined. So we're very happy to have Joe Mutena available from Opportunity International on our panel. But we are missing actually tech for her. Unfortunately, they couldn't make it for today, but we have at least 4 represented. I think it's getting more busy in that space. A few other solutions, very interesting, are within that room. We had on Monday a gathering between the cohorts and other partners, including ISDA on the virtual agronomist. They're also in the room. And some other partners like CGIAR and Keynote from Rwanda. And also Kisan AI who also offer similar solutions. So I think that space is getting more and more busy and builds also upon technologies that we have heard also in the former presentation from the Agri-Tutor side and some of the GIAR results and the REC pipeline that has been mentioned. So I want to give you a quick introduction of what we have done in the Agricultural Information Exchange platform, starting basically with the problem statement. Okay, thanks. So I think for most of you, it's not really news that we have about 1,400 digital solutions in the low and middle income country space, and they are trying to serve small farming systems. Nevertheless, the uptake and adoption is rather limited, also because of the fact that we don't really serve low literacy and low digital skills groups. At the same time, we have a lot of fragmentation. There are so many solutions not well integrated, of limited scale, and they cover only limited domains. So I think there is no solution at hand where farmers can get a bundled service offering tailored to their needs. And then, of course, we heard about hyperlocalization, and that's a first step and one bold step to get more personalized, dynamic, and of high quality of what we offer. So this is certainly something where we also have to take up. So I think it's fair to say at the moment we don't offer farmers the right information at the right time in the right format. And that's exactly what we're trying to solve. And guess what? Of course, we use Gen AI. We have seen a lot of technology fragments this morning already that tie into that space to really get to a point where we can offer that kind of high quality, diverse and personalized and dynamic content. So imagine a use case where we have Rose, a women farmer here in Kenya, who utilizes her feature phone answering a question in her, sorry, not answering, question in her local dialect and get an answer in her local dialect immediately. And that answer is, of course, generated by AI. And as the system is being used, it learns from the user behavior and gets more and more contextualized and personalized. Also very important, and in particular for the CGIAR community, that we want to have access to a diverse set of databases and repositories. So this solution has to be agnostic from the underlying information and data repositories. Now, how did we do that? We actually started in 2023 with a call for proposals open to everybody, received 133 applications, shortlisted 27 of them, and have invited them for 2 ideation workshops in Bihar and India and in Kenya. And then finally selected 4 cohorts. Again, the 5th one came later on board with Opportunity International and DigiFarm, and started to develop solutions, minimum viable products in monthly sprints. So we actually progress iteratively and then track the progress on a monthly basis, and then get together quarterly in physical meetings to exchange where we are, to synergize on the different solutions and to collaborate. In between, we have end user testing, so the human interaction interfacing is very important. And those are some of the impressions of the last 1.5 to 2 years. So this is an overview of the 5 different solutions. You see the different partners. There are quite a number of CG partners involved, including IRI, CIMIT, and CGIAR generally. And then we have Digital Green partners as the 2nd cohort. We have Viamo and partners as the 3rd, DEHAT and Dalberg the 4th, and as mentioned, Opportunity International, DigiFarm, and GRI as the 5th. Now they use different channels. We will give a quick demo that you have a hands-on impression. They use also different NLP technologies, but basically also a joint architecture and approaches that are very similar to each other. So if there's one lesson learned from the project, there is a central service space where we should try to collaborate with each other because everybody will face the same issues. As you can see, the user reach is still limited with DigiGreen most advanced. There are even more beyond 30,000 farmers. Nerea can tell you more, but 30,000 are going back to the AIP initiative. And of course, there are other initiatives where they also roll out their farmer chat solutions. And then we have Dynac with about 1,200 in Bihar only, and Viamo catching up with about 6,800 recently, very fast. And they had with about 2,000 and DigiFarm Opportunity just started in Kenya with 380 users, but they also have done some piloting in Malawi. Okay, those are some impressions from the field, but I wanted to try to play a few videos that you can see the different modalities of these chatbots that have been mentioned many times today. But I think it's good to have a hands-on experience. And this is the first one from Viamo, an early second sprint testing in June last year in India. And Viamo is providing an interactive voice response interface where basically you have a bot that answers in a local language. I guess the voice is not on.
What limit can I give to my cow so that it can feel the hair?
To help your cow develop a fuller coat, Peter focus on nutrition and overall health.
Okay, let's go one day. Okay, now play again.
सेवा में आपका स्वागत है। मैं यहाँ गेहूं की खेती से संबंधित आपके किसी भी प्रश्न के लिए आपकी सहायता करने के लिए हूँ। आप मुझसे सवाल पूछ।
So give us 30 more seconds for trying to get the audio on. In the meantime, if there are already questions, feel free to raise any question that you have already. Otherwise, we will still have the panel planned with some dedicated questions and some Q&A opened up to everybody at the end.
जैसे कि मैं अपनी गेहूं की फसल में कीटों और बीमारियों का प्रभावी ढंग से प्रबंधन कैसे कर सकता हूँ। स्वर सुनने के बाद सेवा में आपका स्वागत है। मैं यहाँ गेहूं की खेती से संबंधित आपके किसी भी प्रश्न के लिए जैसे कि मैं अपनी गेहूं की फसल में कीटों और बीमारियों का कैसे कर सकता हूँ। स्वर सुनने के
What I do, just play it. I will do some voiceover. So we will play the videos. Unfortunately, the audio is not working. But as you can see, this farmer is using a voice interface to ask a certain question and then get an answer accordingly. I knew there is a big risk in showing these videos. But I think we all have deserved some short break, so let's use it, and then I hope we can get it going in 1 minute. Yeah, just let it run, and I can do some voiceover. I know, Javi. I know you have been very well prepared, but those are the things that happen in the conferences, don't worry. Yeah. So if you go to the next video, which is DigiGreen. And sorry, Noah, you can maybe then refer a little bit to the features and functions. That's not coming up to the projector. So I think we give it one more chance. And if that is not working, you can always contact us and we can provide the videos to have a closer look. Okay, try again.
What limit can I give to my
So this
cow?
one is from Digital Green,
So that it
running
can
on a
feel
mobile
the
app,
hair.
basically using voice interfacing and text interfacing.
To help
So
your
you
cow
simply
develop a
can
fuller coach better
prompt
focus on
your
nutrition and overall health.
question in different languages, get an answer as text or voice message, and then have other integrated service like weather forecasts and plant disease management from plant diseases, so integrated services like Plantix as well. That would then help you to identify the disease and act accordingly and get some advice. And then if you give it another try with
What
the next
limit can
video,
I
which is from Dynac.
give to my cow?
And Dynac offers also a mobile app interface where you can text and get accordingly some answers in local language, but you can also use an IVR service to be feature phone compliant and do a voice interaction and get some voice answer in a local language as well. So I hope you got the idea. Please excuse again that the technology did not work properly. I can promise you this technology that you can see on the screen works pretty well. We have nice first results. And we are, as we speak, we have a end user research going on with 60 decibels, where we have early indication that there is satisfaction in our farmer communities and a perceived benefit that they can get out of that advisory. It works not perfect, but this is exactly what we're going to discuss in our panel for now. And with that, I will thank you very much and look forward to our panel and the discussions. Back to you, Kitty.
Thank you, Christian. Now that we have some context of what has happened in the AIEP project, we'd like to introduce 4 of the 5 cohorts who are sitting with us. We have Mayank from Dynac, Noah from Veamo, Neria from Digital Green, and Joe from Opportunity International. I welcome you all. In this discussion, we'll be sharing some learnings, deep dive into user insights, and also understand from all of you about your plans to scale. So to begin with, I would like to start with Dynac. Mayank, maybe if you could answer, Dynac has International Rice Research Institute as a key partner. So how does your partnership with CGIAR helps you leverage existing data and also helps them improve their data sets, and how has it benefited advisory from your front?
Hello. Am I audible? Yes. Yes. Thanks, Kirti, for the question. So if I talk about Dynac, so actually having ERI and CIMMYT as a partner has been very helpful to take forward our MVP on the ground. But apart from it, we have 4 other cohort partners, 4 other partners also, which has resulted us in doing actual work on field and what was being talked about in the previous session also. That's how we have envisaged. So coming to ERI, so ERI is always is more like a academic partner, a research partner, and we are working very closely with ICAR. So having them on the board has got us access to start from somewhere. So that was an initiation point for us. So for example, the CISA system, the Cereal Initiative for South Asia, it has helped us to have a baseline of the demographics, the acreage, the crop production pattern in that region to start with. And then building upon that front has helped us to shape our MVP for the better usage. So this has been one of the fundamental contribution that having IRI as one of the partners, being in the part of the CG system, and they're always towards policy and advocacy and coming with a cutting edge research towards what I would say improving the livelihoods of the farmers. This has been the starting point for DINAC to work upon on the ground. So apart from it, if we talk about our other partners also, so when we talk about IKSL, they have been one of our partners, and for almost 2 decades, they have been witness to the digital extension revolution which has happened in India. So starting in 2004, when the M extension and the all thing happened, so they have been witness to the hard times, the learning, unlearning, and the evolution which has happened during the set, and they have curated over this period of time a whole lot of data, which we see is a real time. So apart from just when we see from the IRI's perspective, it was coming more as a push. It was a top-down approach where they were giving, where we were coming up with certain advisories, certain package of practices, which were coming, but they were at the lower level. They were just limited to a district or a block or a village level, but it was not customizing to an individual farmer position. When we integrated that with the IKSL data, because it was more like a peer-to-peer learning and a validation of a lot of subjects which was happening on the ground, we were able to see light at the end of the tunnel, and we were able to come up with our MVP. So this has been our major thing. And apart from us, there was Dexian. Dexian is right now the epicenter of cutting-edge revolution in agri-extension platforms. And we hope that the kind of data sets they are having, multiple, working with different partners in Bihar, with Microsafe Consulting and expected data sets, this is also something we look forward to. And then, of course, us at Samarth as well as Graham. So Graham has been into localized intelligence in crop prices and market-related advisories. So this is something what farmers look at. And us being on the ground, being the last mile connector and the eyes and the ears of this entire cohort, it helps us in validating in real time. So having all this thing working for us has essentially been one of the key component for us working as a DINAC, and this is something what we have envisaged.
Thank you, Mayank. It's very interesting how you have worked at combined the top-down research from CGIAR, collected ground level insights, and also being the ears and eyes and mouth of the farmer, and develop a solution which is actually very relevant, especially for female farmers. Now, I would like to move on to you, Noah. Noah, Viamo has been in IVR solutions for decades, and you work across sectors. And we want to understand how your user adoption journey was different in agriculture as compared to other sectors.
Thank you. Hi, everyone. My name is Noah. So at Viamo, we do use IVR, which is interactive voice response. So we use it as a channel, one of the channels that we have, to deliver training and digital advisory for all communities, just using a simple mobile phone. So we do not need internet, smartphones, and it helps us reach underserved communities and it connects us with digitally disconnected communities. All right, so I'm going to give you a few examples. First of all, in Kenya here, and in India, and in collaboration with GIZ, the project we just watched, we've taken this further, not just digital trainings, but we built an AI-powered tool that allowed us to provide farmers in Kenya and India to ask their questions using a simple basic phone, call a dedicated hotline, and ask their questions in their local languages, Kiswahili, Hindi, or English as an option, and receive instant real-time advice. And then we also, the good part is we have built dashboards that help us compile all the responses, the questions and answers that help us
reach better, scale up this project and reach and do better optimization of our services and help our farmers better. But also in Nigeria, we built a similar tool, but now we are helping choose or community health workers from Nigeria who often serve remote communities. And this tool allows them, while they are in the care of a patient, to ask questions about treatment protocols, or if they want guidance on how on case guidance or treatment guidance. And what they need to do is just call this digital assistant from a simple basic call, again, free of charge, and ask their medical questions and receive instant advice powered by AI, of course. And then again, a dashboard that helps us compile all of this data and find out what we can do to help them better. What are the questions that are coming? How can we improve the tool to help them serve them better? So another use case is in Sudan. We built a similar tool to the one that we built here in Kenya and India. So this was targeted at farmers and in Sudan, where it's a conflict zone, and most of the farmers were hard to reach. We built this AI tool also via IVR using basic phones for free, completely from all networks, where farmers can just call and ask any questions about farming, pest control, or soil fertility, etc., and receive instant advice as well. And then at the end, if we want to compare sectors between what we did in health or what we did in agriculture, so adoption in agriculture has been especially or significantly strong. We've noticed that the farmers that we addressed via IVR across the world are eager to learn, and they want to share their learnings. They want to use their learnings because they want to improve their livelihoods. But we've seen this strong engagement as well across other sectors, like in health, like in education, disaster response, financial literacy. So our end users want to learn and they want to share their knowledge because this tool is available to them to be used while they're in the field, in the case of farmers, in the clinic, in a classroom for teachers. So adoption, so IVR, in summary, IVR is not just a tool for communication, but it's a powerful, proven method for knowledge transfer and behavior change, and that's the most important part, in agriculture and all other sectors. So, because the last thing is, when we top it up with AI as well, it provides you with a free tool. It provides you with inclusivity. You can reach communities from underserved areas. As we said, also digitally disconnected communities, areas with conflicts, and it's completely free and in local dialects. Thank you so much.
Thank you, Noah. It's very interesting to see that how you have combined high tech with high context and high inclusivity. And yeah, the farmers and community workers are eager to learn. That's something we often forget. And when we can meet them with the tools and tech of their choice, we can empower them. Now, double click on the user experience. I would like to come to you, Neria. And the Farmer Chat application has 100,000 of users across the world. We want to understand from you what are your experiences in user acquisition, acquiring new users, retaining them, and what are your scale out plans for India and Africa, and maybe you can divide it separately for the Indian and African strategy.
All right, thank you. Thank you, Katie. Hi, everyone. Okay, so I'll start by giving a bit of a background into how Digital Brew came into AI, because we've been there for about 15 years. So we started by experimenting with AI by using Telegram as a channel a few years back. So we are currently in India, in Ethiopia, in Kenya, and in Nigeria. We actually have 170,000 users at the moment. But in the fourth quarter of last year, we rolled out our mobile app, Farmer Chat. And that's where we have the 170,000 users at the moment who've asked about 1.8 million plus questions so far. So what have we learned so far as we rolled out both the Telegram app and now are continuing to roll out the mobile app is we have adopted a multi-pronged approach in recruiting new users. So number one, we leverage off of digital advertising. So we find that there's a lot of farmer communities on places like Facebook. So we do a lot of digital advertising, particularly in Kenya. And then we also have physical onboarding, both in Kenya and in Bihar. We do a lot of physical onboarding. We call that in-person onboarding. And with the physical onboarding in particular, we find that one of the key factors to our success is partnering with local government. So in Kenya, for example, we leverage off the county officials and we use them to mobilize the farmers on the ground to come to the spaces where we onboard these farmers onto Farmer Chat. Now, trust is a huge factor for farmers. So as you go into the field, if you don't go with the local government, you're most likely to face a lot of resistance. So partnering with local government is very important, something that we have found out. The second thing that we do is both in Kenya and in Bihar is ahead of the onboarding sessions, as we call them, we kind of educate the farmers to come to the sessions equipped to the smartphone and with mobile data, because this is a mobile app, so it will actually require of them to download it from the Google Play Store. It's an Android app, right? So we tell them beforehand, get some mobile data, have a smartphone, and so that it makes for a smoother experience during the onboarding sessions. We've also found that particularly with older farmers and with women farmers, we have to provide a lot of visual materials, so visual aids and tutorials as well, just to help them along in the training process as they're onboarding onto Farmer Chat. You have to train them, you have to go to the Google Play Store. Here you have to download it this way. So we provide a lot of that material, and we provide it for the online users as well, the ones who are onboarding digitally. The other thing that we have found out is to provide a set of smart questions as practical examples, because for a lot of these farmers, it's the first time that they're interacting with chatbots and they don't necessarily know how to ask the questions. It's not the same way that they would ask their extension officer for advice. So in their mind, when they're talking to a bot, they're talking to a robot. So they will say something like, my cow is sick. And that's not a smart question. So we provide smart question examples at the session so that they are able to kind of get into the practice of asking questions that will get them the right information. So that's another practice that we've gotten into. The last thing I will say about the physical onboarding is peer learning. So we've learned that particularly with women farmers in mixed group settings tend to be very shy. So when male farmers speak up in Africa and India, women farmers tend to keep quiet. So we'll peer them up. We'll put a woman farmer and a woman farmer together, and that way they're able to learn together and onboard, and this builds their self-confidence. And after the fact, you'll find even when they go home, they engage with the app by themselves because they've already built into the habit of using the app. So those are some of the learnings that we found. Now, post-engagement of actually onboarding into the Farmer Chat, we actually keep track using our dashboards. We have human-in-the-loop interactions, and we keep track of what the user engagement. So high user engagement, we call these users super users. And we then recruit these users onto Digital Green for a program that we call Community Champions. We use these community champions to then refer other farmers within their local community so that we keep growing the Farmer Chat interaction and we keep learning from each other. We've also learned that farmers trust other farmers, right? So it's easier if they're learning from another farmer how to use the app. So we found that that program actually really works. So that's the last thing I'll say about the learnings. In terms of scalability, I think that was your next question. Yeah, all right. Or did you want to say something before I proceed? Okay. All right. In terms of scalability, so right now in both Kenya and Bihar, we have rolled out this mobile app in specific regions. Now, the reason we've done that is we want to take our key learnings on our user needs, right? So we've had these conversations that we've had from the room that farmers, especially smallholder farmers, they don't really only need advisory. They need market input. They need outputs, right? They need access to credit. So there's actually things that they need. So we're learning this as Digital Green and then through our partners as well and through the ecosystem. And as we're taking in this learnings, we're kind of building this roadmap of what we want to do, as well as trying to find a balance between onboarding these users and retaining them within the app, right? So we're trying not to go big, but kind of find this delicate balance before we scale out. So once we found this balance, the plan is to scale, of course, to other regions. And as we keep hearing, the ecosystem is fragmented, so we can't do it alone. So as we go out and we plan to go out into other regions, both in Kenya and in Bihar, our plan is to then collaborate with private and public partners so that we can scale and take care of the 360 needs of the farmer. The other thing that is important to mention is there's a large percentage of farmers out there that use feature phones that are using channels such as IVR from VMware, and mobile apps from us. And so it's important to collaborate and do this together and provide IVR, SMS, USSD mobile apps. So like I say, private and public partnerships, so we can bring this all together and take care of the feature phones as well, so that we actually take care of the larger addressable markets.
Thank you, Miria. That was really great. I think, collaborating with local governments to build trust and offering solutions, not just advisory, but also offering them access to inputs. That's really important for you to gain trust in the long run for farmers. Now I'd like to come to you, Joe. We've spoken about technology, we've spoken about user acquisition, but we all know that all this tech comes at a huge cost. So if you want to scale up, you need to have business models that can help you reach wider audience. So what is your long-term business model, and how do you plan to integrate the advisory bot into your existing farmer services portfolio?
Thank you, Kirti. I think the first place to start is where we are as Opportunity International and DigiFarm. And I would like just to explain that we 2 months ago, we launched a pilot project between DigiFarm, Safaricom, Opportunity International, and GUI, who are helping us with the integration of the solutions. So the essence of the pilot stage is to learn the lessons. It's a new it's a new technology with vast potential. How do you apply it to small scale farmers? I think even in the session that was here earlier, someone mentioned, how do you connect the science to the farmers? And I think out of the piloting is where the lessons are learned. We've had the benefit of coming after the other cohorts. So there's already a lot of learnings that we are picking. But just to give a sense of our journey is that we started off with a very limited geography and also one value chain, which is the potato value chain, and focused in a place called Nyahururu, somewhere in central Kenya. And the understanding is what lessons can we pick with this one crop, in this one geography, in this one language, which initially was English, but we're also using Kiswahili. And obviously the vernacular context will kick in at some point. So out of those engagements, you pick lessons, and those are the lessons then that you are able to scale up with. I would want to say that in terms of business model, the way we see it, it's anchored to what is the journey of the farmer as they do their farming. From pre-production to production to post-harvest and to accessing the market. And one of the advantages of being in a partnership with a huge organization like DigiFarm, Safaricom, is that they have a vast network.
their mobile platform already has very many farmers who are coming in to tap into information and also various financial services. So that gives us the benefit to then say, once we've tested this mini MVP solution that we have, how do we apply it? How do we scale it? And I think that goes to the gist of your question. I would want to say that for all the science, for all the solutions, I think from a farmer perspective, what the farmer will be looking at is, how do I increase my yield, my productivity, and my income? And any business model has to answer that question for the farmer. So our perspective is that we need to look at the sustainability of our business model first by what is the value proposition that the farmer is going to get out of these products. And I would want to say that if the knowledge is there, and I think it's a very critical input for farmers to have the right knowledge in the right context at the right time on demand. If that knowledge is there, then the business is anchored in a way with a strong foundation. Now, in terms of what model we would take, and there are two ways of looking at it. You could say, I have these AI advisory chatbots. Do I have it as a standalone, or do I integrate it within a larger ecosystem? And at this early stage, we would be leaning towards integrating the AI so that it's a front-facing addition to a larger ecosystem that serves the farmers as they go through their season. Now, do you charge the farmers for the services that we've talked about? Can they afford it? So affordability kicks in. I think there are different aspects, whether to do a B2B, where you deal with agro-businesses and input companies, and the revenue comes that way, and it allows you to give the farmers the services at no cost. Sorry.
Yeah. You have one more?
No, it's okay. I think I just, so whether it's a subscription, whether it's a B2B, whether it's a government supported or donor funded, all those, but I think in terms of a sustainable model, it has to answer the question that the farmer can afford it, and they're able to access and utilize the information in a way that they're able to see the outcomes that they want on the farm. Thank you.
Thanks, Joe. I think it's well put that the value proposition for the farmer needs to be clear first, and then only we can talk about the subscription model, and it could be various. I believe we have already overshot the time limit for the session, but do we have any burning questions? We'll just take one, so maybe you, sir.
Okay. Good afternoon. Yes, I'm Maulana Lucas. I'm a programs manager for the Earth Observation Innovation Lab under the Kenya Space Agency, located at the Southern region at the University, Taita Taveta University. So maybe based on what has been shared, this AI linkages to the farmers, the smallholder farmers, as a center of excellence in a number of projects supporting the Kenya government. We have realized that there is that gap, what was shown as statement of the problem. Clearly, it is there, information gap, but what I need to know on how we have been trying to run this AI platform, the Agriculture Information System Exchange, to the ground. Are you training the lead farmers? I've heard from Safaricom that they are working with the lead farmers. We have done one project with the Kenya Red Cross on integrated food security and livelihood. And through that, we realized that these lead farmers need to be trained. There is the issue of gadgets. That is a problem also on the ground, because most people have to use SSD. These apps, most farmers don't have, unless you give them the phones yourself. They don't have them. So that is the reality on the ground. So maybe what are you doing on that? Number one, on the training, because myself, I'm based in the university. I train people for master's program, bachelor's program in GIS and remote sensing. So, and they apply them in various areas. So maybe on the training components, what are you doing on that to bring this to the ground? And then you have talked about working with the county governments. I'm located, my area of operation is the coast region. I'm working with the 6 county governments, the Jumuiya counties of one region. So in these county governments, in this information system, which you're using on AI, on voice or other things, are you updating that information? Have you trained the county government people to be updating information on a daily basis from the extension on the ground so that you have the right information? Because there is the issue of climate change and the crops are varying in the different agroecological zones. So for the farmers to get, because what is applied in Murang'a cannot work in Taita. What is working in Kisumu cannot work in Mount Kenya region. So maybe for the essence of updating that information, have you trained so that this model can be applied in Taita, can be applied anywhere in Kenya, but based on the actual information updated to the system to give the right output? So maybe those are the clarifications requested, but I'm happy to partner in these activities. Thank you.
Thank you, sir. I think from the first question, Neria already answered that they will work with champion farmers. And on second, Neria, Noah, could you give a yes or no answer? Otherwise, that's a valid point and we could do that, take that up.
No problem, I'll take that question. So for the counties that we are in, yes, we have trained the county officials. We start all the way from the government level. So by the time we're getting into the county, we actually train the county office. We have a dashboard that we expose to them as well. With regards to the data is actually automated. And in the earlier sessions, you saw that the content that comes in is package of practice content. So it comes all the way from Calvo. So that's the information that gets into the AI system that is passed on to the farmers. We also collaborate with the counties to get content from them to get into the bot. So all of this information is the one that goes in to feed the bot. It's very hyper-localized. We have the term hyper-localized. So the information that they are getting is very specific to their localized area. So with regards to that, my short answer is yes and yes.
Thanks, Neria. And I think there might be other questions, but we'll have to close the session in the interest of time. Okay, is it? So, but you can, we are all around and we can speak one-on-one if that helps. And now I'll hand over to Chandli. Thank you.
Okay.
Thank you so much. I believe we have already witnessed a very unique case wherein we are trying to strengthen the extension system through AI. So our next session is on analyzing Earth observation data using AI. And we know that Earth observation tools help researchers generate new insights on multiple scales, from global assessments to farm level interventions. So with this, I would really like to welcome Charles and Jemima from University of Galway to take over and present. Thank you so much for being here.
Thank you so much. And so my name is Charlie Spillane from the University of Galway in Ireland, and I'm co-presenting with my colleague here, Jemima O'Farrell. So we're delighted that the session organizers invited us to give a talk. So the title of our talk is Earth Observation Analysis of it using artificial intelligence. And as a preamble to this, I should say that the body of work that we're presenting here is work that we've been doing over the past 4 to 5 years, which was initially initiated as a partnership with the Alliance Biodiversity and CIAT, and namely Andy Jarvis, Ana Maria Lava Guerrero, and also our colleague, Louis Raymondin, apologies. So it's a body of work that arose from a Grand Challenges program that we applied to back around 2021, 2020 or so. And then we were the prize winners of that. So Jemima is going to present, how far we got in developing a platform for analyzing Earth observation using AI. So next slide. No, I can do it. That's it. There we go. Yeah. So I don't need to remind everybody in this audience that the climate change adaptation is one of the 3 major climate change challenges of our time. And if we look at the agricultural arena, it's critical that climate change adaptation, that we achieve that over the next decades and over the next period of time. We have about 20 million kilometers of agricultural land that is currently at risk of climate change that requires adaptation measures. And the footprint of people that whose livelihoods directly depend on that is over 2 billion people. So it's really critical that effective adaptation measures are put in place over now and in the decades ahead. So clearly, they need to be reflected in the policies and the plans that are underway within each of the countries, in our NDCs and our national adaptation plans. And consequently, there arises a major need for climate adaptation financing in agriculture, but also there are increasing requests for that financing to be accelerated and deployed. So we do know that a lot of work has been done on what are the most climate vulnerable agricultural systems. Extensive work has been done in that regard. So from that point of view, it's really important to, it's important to consider that we need to have some form of measurement of climate change adaptation in agricultural systems, because if we want to use that investment, those billions and trillions of investment wisely, we need to know which adaptation measures work better than others. And that's really where we began developing what we call the TAPES platform, which is tracking adaptation progress in agri-food systems. So really the need arose from the lack really of a universally deployable or scalable system to measure and monitor climate change adaptation in agricultural systems. So within the UNFCCC context, we know that the UAE BELEM process has been considering thousands of indicators of adaptations, but in some sense, there's a need for some standardization and interoperability of indicators that can measure climate change adaptation across countries, but also across different scales, from farms to landscapes to national scales. And that's really what the challenge that we set out with this Grand Challenge program. We also see a major potential for what we've been developing as a means of assessing the effectiveness of different types of climate change adaptation investments. And so from that point of view, really, we set out, you can see at the bottom of this slide, to develop a platform that would measure climate change adaptation in agricultural systems at different scales. And at that, I'm going to hand over to my very talented team member here, Jemima Rafal, who's going to walk through the work that the team have been doing over the past 4 years, and then I'll come back to you again later.
Thank you very much. That was a very flattering introduction, Charlie. So I've been working on the tech side of this project, so I'm going to walk through, for the most part, just some examples of results that we've achieved over the last couple of years. So the TAPES project, which was the first project mentioned, focuses on tracking climate adaptation and progress in agricultural systems specifically. And these are just a few examples of the things that we do using remote sensing and AI, and these are insights that we find to be useful in analyzing these systems. I heard a quote earlier this week about how the surface area of land that we have is not changing, but we have more people to feed. So we need to come up with really creative solutions. And mapping and monitoring land use change is one of those that can enable us to look at agricultural area as it expands and how things like deforestation and urbanization shifts those patterns in time. We also really look at vegetation health and crop productivity at the farm scale. And this leads into assessing the climate risk and measuring the adaptation of those specific crops as well. And at the backbone of this as well, specifically in sub-Saharan Africa, is monitoring water availability. We do this from soil moisture all the way down to deep underground aquifers using a range of different instruments. And another important thing towards the future is looking at extreme climate shocks and seeing if we can forecast those, things like floods and droughts, to develop early warning systems. This is a very active area of research at the moment. So I thought I'd start off with a project we did assessing quite a large investment in the Senegal River Valley region. This was $170 million put in by USAID. The project finished in around 2015, and the overall goal was to boost rice productivity in this region. So this area typically relied on subsistence farming, and so they would wait for the rainy season. The majority of rice grown in this area was rain-fed rice. There was a huge push by the government to move away from the heavy reliance on imported rice, and they wanted to grow more of their own food to be self-sustaining. So this project really fed into that goal at a government level, and we decided to analyze this end-to-end using just data from remote sensing platforms. So this is really where we started off. The two main goals of the project were not only to increase the agricultural area in the region, but also to increase the productivity.
So by putting in a really extensive irrigation system, the region was able to farm not once a year when the rains came, but twice a year. So this already doubled productivity in many areas. We are also able to expand beyond the riverbanks into areas that were fed purely by irrigation. So we trained a deep learning model on satellite imagery, and this fed us the information where we could split the area into 4 different classes. So we have fallow land, which is not being currently farmed by any crops at all. We have dry season rice and wet season rice, but most importantly, we also have the double cropping rice. So this is where we see 2 peaks every year in the agricultural productivity of that parcel of land. And an easier way to really look at this information is through a bar chart. So we've really compressed it down here. So using this AI satellite remote sensing fusion here, we were able to see that the double cropping area did expand. We saw about 15,000 hectares of land that was either previously fallow or single crop moved to this double cropping practice by the end of the project in 2015. However, we did see that this sharply declined by about 45% in 2021. It didn't take too much digging around to work out that that was due to COVID cases in the region spiking in 2021. So there was quite harsh restrictions on practices in the region and inaccessibility to facilities that you would need to farm. However, what concerned us most about this information is that the decline continued to persist post-COVID. So we can see that 2024 is actually one of the worst years for double cropping that we've seen so far. So we went back to the drawing board and we looked at, well, what caused this boost in productivity to begin with? It was the irrigation infrastructure. So we decided to look into that infrastructure in a more detailed manner. Using more satellite data, we were able to look at the irrigation canals and essentially analyze how well they were being maintained. So dredging is really important in this region. They also have a lot of very invasive weeds that end up in these canals and they take a lot of oxygen out of the water, but they also cause water loss through transpiration. So we need to make sure these canals are being maintained, and we were able to use the satellite platform to essentially come to the conclusion that in many areas they were not. So we developed this map of the canals in the region. Those in red are those that have now declined in both water levels and have become inundated with weeds. So then we were able to really boost productivity with the irrigation infrastructure, which was an incredible gift at the time. It's not a long-term solution unless there is a way to maintain this. And this is the kind of feedback that we find is really important when you're looking at these large-scale investments. So we did get 2 out of the 3 outcomes: an increase in cropping area, yes, and an increase in cropping intensity. But the thing that really underpins these in terms of climate resilience is the maintenance of this irrigation network. Now, we did also look at the climate background at the time. And what was really interesting is at this point in time, so from around 2016 to 2019, they were actually suffering severe rainfall anomalies in this region. So there was a lack of rainfall, but because the water bodies were able to carry it from the reservoir to this region, the local precipitation patterns did not impact people as much as they would have. So we did still see a lot of double cropping happening at this time. So that is an end-to-end analysis using just remote sensing. But this is something we're looking to build on top of that, and we're looking to run this in numerous different case studies in terms of human interventions. And this is measuring climate adaptation with deep learning. So this has taken a bit of time to develop, but it is the core of the TAPIS platform. So what we did is we took data assimilated climate models, and we trained a model on guessing what the agricultural outcome would be based on the current climate. And we did this for very historical data. And now what we do is we run that same model on current climate scenarios. And this gives us essentially an estimate of what the crops should be doing based just on the climate alone. And then from this, we can infer either adaptation or maladaptation. So adaptation in this sense is when the real observations are outperforming what is predicted based on climate alone. So this likely means that there's been some kind of intervention to help the crops be more resilient to what's happening in the climate at the moment. But we also have the other hand, which is maladaptation, which is where things aren't doing as well as they should be. And this could be due to the selection of a very specific strain of a crop, or it could be due to fertilizer use. But this really gives us an indicator of where to look, essentially. Now, we've also been doing some collaborative work, and this comes back to rice again. You'll notice an underlying theme, but I promise we are about to branch out. So this is looking at measuring alternative wetting and drying. And this is an initiative that kind of falls under that mitigation strategy. So we're working on this with IRI, the International Rice Research Institute, and their goal is to monitor how often these practices are happening. So when rice is being grown, the fields are flooded, and they're typically flooded throughout the whole season. The goal here is to drain the fields every now and again, so you have reduced methane emissions from the water. And by tracking this, we can hopefully incentivize this with the farmers, but we need to be able to monitor it at quite a local scale. So we've developed another algorithm. This is a machine learning-based algorithm, and we're looking at flood detection in these different paddies. So you'll see this cycling through. This is just over a year of data. We have 3 seasons in this region, and this is a very large-scale summary of the results. We are still working with IRI at the moment to validate these results very robustly, because of course, if you're going to incentivize people to take up cropping practices, you need the accuracy to really be up there. We're currently at 88%, but we do hope to improve that. Now, on the topic of water, we are also looking at soil moisture monitoring. This was mentioned this morning. It's a very hot topic at the moment, specifically because it's quite difficult to do sometimes. But a very smart colleague of mine, Pierce Murphy, has developed an algorithm to do this. And we ran this in a region in Malawi. And I won't go into the details too much. The paper is really a fantastic overview of the results. But we observed a few different things. So we looked at an area in the Kasunga region, and we noticed that the soil moisture retention in this area was higher. And we were also able to observe the effects of conservation agriculture as well. So there's a lot you can derive from the soil moisture measures. And we also looked at the Luanda National Park region. We took a small region outside this area as well, and we were able to observe a few things, but most importantly, there was a faster response to rainfall in this region. So essentially with this, you can monitor for drought. You can look at areas that have a higher water retention, and you can also look at areas that may be more prone to drought risks as well. Now, this is another body of work that my colleague has produced, Yara Tessma, and he's working on using satellite remote sensing to map ground nets. It was a very successful project considering that the ground truth was very limited, but we were able to build a very robust model with this that generalized incredibly well. And we've mapped this for all of Malawi, but we actually have great plans to expand this now. So I'm also working on the Like for Dev project, and we're hoping to use this and essentially build on the algorithm to map over about 20 different crop species. About time, no problem at all. So I'm gonna skip through these last few now, but I think I've covered all I really need to cover today. So we also have the Eco Food Systems project. Feel free to approach me and speak about that at any point. But we're also focusing on food systems in cities. We're looking at urban gardening. We're looking at a few different things. And essentially, we're going to layer all of this data on top of the multidimensional poverty mapping analysis that we did. And we're looking at healthy, sustainable diets is the overarching theme here. So I think I'm going to pass back to Charlie now to wrap up. But feel free to approach me if you want to discuss any of this further. We have a whole plethora of use cases. So thank you very much.
Thanks very much, Jemima. That's a really wonderful overview of what we've been doing. And so I guess from our perspective, we really, we see the need to measure what climate change interventions and investments in agriculture work best. And we think we've developed the bones of a platform that could be used for such activities. We're pretty convinced that satellite remote sensing, I think everybody in this room is also convinced, is really an exciting arena, and the fusion of that with AI allows lots of opportunities, which I think we've kind of demonstrated. So we have a powerful approach, but from our perspective at where we are now in terms of the TAPAS platform, what we're really interested in is building partnerships with other organizations, CGIAR and beyond. We're particularly interested in trying to connect the donor community to look at use cases to evaluate past large-scale agricultural investments. And so we could look at before, during, or before and after, and to see what effect they had on the the expectations in terms of effect and whether that matches with what the post project evaluations actually indicated. And so we could do both post hoc and also look at current projects. So we'd be quite keen to connect with any of the donor community or indeed the investment banks if they wanted to look at their portfolio of projects using the platform. And we're also very open to kind of use cases in partnership with any others that might want to contact us. So in terms of, I'll just finish up on this very last piece, which is really just an acknowledgement. This is work that we developed in the University of Galway. The people involved in this, my colleague Erin Golden, Júlta Finnegan, Mike McGeever, Patricia Codar, Chris Murphy, and of course, Jemima. But we also work very closely with Andy Jarvis, Anna Maria, and also Louis Raymondon and Tiffany Talsma. And the rice work was with Katie Nelson and Ole Sander and Guita. Okay, so thank you. And if you want to contact us, just to reach out.
Okay, thank you very much. Any quick question? We don't have much time, but maybe just one or two. Oh, yes, go ahead.
Thank you. That was really fascinating. Is there a way to overlay this with data on ownership by gender of plots or other gender data so that we also can understand the gender differences in climate adaptation? Thank you.
Thanks very much, Alice. So this, when we made the initial pitches of this in the challenge program, we didn't want to make the claim that everything could be measured in relation to climate adaptation, simply by satellites, but we think it's very powerful to augment. So in some ways you can consider, we can pinpoint regions which are like a black box and say, this is regions performing pretty well, this is performing pretty badly, and the people on the ground can go and look and find out what that is. So it could be overlaid and geospatially connected. So there is a potential to do that. It depends really again on the data sets that are underlying that and whether they're kind of temporal and geospatial. But the integration of those would be a means to develop the intelligence engines to really evaluate whether development projects are performing, per unit investment.
Okay, great. Any other questions?
On that one, I'm going to hand over.
Thank you. Okay, I'll give this a go. As I said, my very talented colleague led that body of work. But in terms of remote sensing of soil moisture, it depends on the instrument you have. There are some very long wavelength satellites now that can penetrate through the crop canopy. So even if there is a crop present, you can still measure the soil moisture that crop is growing in. So we would be inferring it from the soil moisture as opposed to the moisture in the crop itself. But I think that is also a body of work that's quite active at the moment as well.
Okay, great. Thanks so much. Please give a pass to Chancellor Jemima. Okay. So I think if you were together with us since this morning, we had lots of technical challenges. Now we have food security challenges. We actually didn't budget time for food, but our caterers are waiting outside when the session is going to end. But it took a couple of hours. So we decided to have just quick break, 10-minute break. So there are tea. I don't think you have to watch out for coffee, tea, and some snacks out there. So that means we will delay the following two sessions just 10 minutes. I hope that's not too disrupting. Thanks for your understanding, team. Please come back by, let's start at 1:30. So let's start at 1:30. And we just learned also there is no other session planned for this room. So we will give enough time for the Artemis team to go as we need. So sorry for this, but thanks for understanding. Okay, we will come back at 1:30. So if you're online, we will have quick break because we've been running since 8 a.m. We will come back in 10 minutes. Thanks. Sorry. I got logged out. He couldn't come, so he's listening. Sorry. So we will give you 20 minutes. I think that's really great. So he will give remote presentation for 20 minutes, and after that, you take as much time you have. Yeah. Sorry.
All right, thank you. Yo. Hello, 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 hello.
Hi, Benin. Can you hear us? We don't
Yes, I
hear
can hear you
you.
loud and clear. Your voice is, I can see and I can hear. I don't know whether I am audible.
No, it's not. Well, now it seems. Yeah, but this is coming from my left. So,
Can you hear me, Javu?
we cannot hear you. We cannot hear you.
Oh my God. Uh, but can you see me? How about now?
We got you. We got you. We got you. We got you.
Hello? 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 Hello?
Hello? Hello?
Hello.
Hi, Bernard. Can you say something again? I'm sorry, we're testing.
Can you hear
different
me?
things.
Can you now?
It's not coming.
No.
Oh, that didn't echo. Yours didn't echo. That's good. Also, won't echo. Listening? Try again.
Hello. So yeah, it's online. Yeah, online. So it's okay. It's just in the room. You don't hear Venom.
Oh.
What's his name?
Vino.
Vinu, can you hear us here? Thumbs up if you can hear us. Thumbs up if you can hear us because we're not getting your audio. Check if you're muted.
Here. So if I do that, then I can hear.
No. Well, you see, if we're not using, don't in that.
You want to have the microphone settings?
No, guys. The audio is coming through our system, not through the laptop. So we are not using this.
What about the
It's going through our system.
But then why don't we hear it?
But since the online participants can hear,
Kindly speak, Vinu.
hello, can you hear me?
Yes, we can hear you.
Okay, perfect.
So Vino, can you
Yes.
try your screen to see if we can see it?
What was that?
Can you try sharing your screen, your slide?
Oh, you want me to share? I thought you're sharing. Okay.
Yeah, I have your presentation as a backup, but yeah, if you have it yours, if it works, then it's better.
Okay.
Yeah, we can see it. Good.
Works. Okay. Great.
It works. There are some black.
It's moving.
I don't know why. Okay.
Are the slides moving, Jawu?
Yeah, slide is moving, but on the right hand side there are some boxes. Do you see like chat? Yeah, that window. Can you just close it on the right hand side? Yes, that one. I think that's a Zoom window or something.
This one?
And then on top. Yes, good. No, I think this is okay. All right, so we will start in 3 minutes. Thank you. Thanks. You're the best. Penu, we are seeing your speaker view. I think you have to swap the monitor, swap the display. Yeah.
What should I do?
Go to display settings on top. Yeah, or yeah, that works too. Yeah, hide presenter view. Yeah. Yes.
This one?
Yeah, okay then.
Okay, thanks.
Okay, thanks.
Good afternoon, everyone. I'll request everyone to please join and come in. So our next session is on AI applications for crop diversity, conservation, and gene bank use. Gene banks are a key resource for conserving, managing, and accessing crop diversity to cope with climate change. Yet they are largely underutilized, mainly due to lack of information on the usefulness of its access. By adapting and applying AI, gene banks could reduce cost and time to 1/16 and 1/10, respectively, of the business and usual approach. This presentation will increase awareness about this approach. So it's my privilege to welcome Venu Prasad, my colleague from ED, to actually talk about this topic. Venu, over to you.
All right. Thank you, Shalini, and good afternoon, everybody. I would like to thank the organizers for giving me this opportunity to speak. And as Shalini mentioned, I will be talking about AI in gene bank management and use, and I will take the International Rice Gene Bank, which is based in Erie in Philippines, as a use case. I hope I'm audible, Shalini. So some brief definitions about AI, ML, and DL, but probably this group is already well aware of this, so I will skip this. Again, in terms of AI, we are still in early days, still a long way to go, so exciting times ahead. So coming to the International Rice Gene Bank. So what is a gene bank? Shalini already mentioned. In our case, it is a bank where we store seeds. So it is as simple as that. So the International Rice Gene Bank, which is based in Erie in Philippines, is one of the oldest international gene banks out there. It was established in 1977, and it hosts the world's largest collection of rice diversity. Over 132,000 accessions are there, and it is said to be the most diverse collection and most complete collection, because the material in the collection has come from over 134 countries. And all the wild species of rice is also conserved here, including the 7 related genera. This gene bank is said to be highly used because on an average, we dispatch up to 45,000 samples every year. And from the reviewers and external supporters have indicated that this is a well-maintained gene bank. However, we still have a long way to go, because we want to be a next-gen gene bank. We want to be a next-gen gene bank by adopting latest technology available out there to improve our efficiency of operation, as well as to improve the efficiency of use of the collection. So today I'll be focusing about how IRG, or International Rice Gene Bank, is utilizing AI-based technologies to achieve its goals. So in a gene bank, several activities are said to be routine activities, and here we give examples of how AI can be used to improve the efficiencies. And here, this talk is about telling what we are doing, and it may not be an exhaustive coverage of all the applications of AI in gene bank. This is what we are already doing or applying at our gene bank here. So here, as I mentioned in this slide, one main application is to improve the routine operations of the gene bank. There are a lot of operations which are considered as routine, which is seed cleaning, sorting, viability testing, authentication, and characterization. We can apply AI to increase the efficiency, reduce the cost of doing business, which is an important KPI for a gene bank. Then we can also apply AI-based methodologies to improve the understanding of the collection. Many times in the gene bank, we have a lot of material, but very little understanding about the collections. And understanding has been being generated based on some morphological basis, using conventional method, or also by gene the sequencing of the collection. But we can also bring in AI there to improve the understanding of the collection. We will present some examples of that. We can also use it in data curation, and also to enhance the use of the collection. We can also use it to improve the user experience, which right now is not so great. So coming to basic operations such as seed sorting and cleaning, some of the methods I am going to mention is some have been developed in-house, some have been adopted from publicly available information. In some cases, we have bought from companies the products which have AI inbuilt in their offerings. So this is one example where AI is actually inbuilt in one of the offering. It's a robotic based system where the seeds are completely sorted automatically, and it uses AI-based ML-based methodology to see which one to keep and which one to reject. This before used to be done manually. You would, if you come to the gene bank, you would see dozens of people sitting and cleaning the seeds and deciding what to keep, what not to keep. But now the machine can do it very effectively and utilizing the ML-based models which are inbuilt in it. The other application is in seed viability monitoring. We have to always check whether the seed that we have are alive or not, or what is the condition of that. So for that, we do what is called as viability testing. And for that, again, it is generally done in a very laborious method, but this can also be automated. And this is an example here where robot and AI-based applications have come together to do this viability monitoring. It's in a semi-automated way. So once the seed is loaded by the researcher, the rest of all the work is done by the robotics. And the AI-based methodology comes in and tells and gives the information about that particular sample. But at the same time, we are also developing new models where some of these can actually be predicted rather than be tested. So this is coming in the next iteration probably. Then about seed characterization, this is an important task for almost all the gene banks. So this was again done by manually. Before you would see people sitting in front of a microscope to do and study the grain parameters, the shape, the size, and all. Nowadays, many of these can be automated. And AI-based methodologies here is an examples of how an instrument called videometer, which already has ML-based methodologies inbuilt into it to do some of these stuff. So what are things this can do as of now in collaboration with our colleagues from Videometer? So these descriptors have been, these descriptors can be measured just by the image analysis, which is inbuilt into the system. So you can say, if you know what is meant by a FAO-based descriptor for each crop, there's a length of crops. For rice, more than 50 descriptors are there. Some of them are seed-based, so these things can be easily automated, and accurate information can be extracted about that particular variety or accessions. We can also do more nowadays. So we are already doing this one. Before, as I said, that some of the dimensions of the seeds we used to collect manually in front of microscope, very tedious, laborious method. But from that method, we have moved on to now ML-based method, where by just using computer vision technologies, we can easily extract information by taking an image. And for this, we are actually using the publicly available ML models that are out there. Now, coming to the newer traits, AI has enabled us to venture into new traits which was never possible before. We were not doing it or conveniently ignoring it because it was too difficult. One of the trait is panicle architecture, which is an important agronomic trait. Before we couldn't do because it was too cumbersome and challenging, but now very nice methods are available, and we are already started to use. And now you can extract information about the rice panicle architecture. How does it look? What is the branching? How many seeds? And even the size of the seeds and all can be actually be estimated using simple ML-based models. We also ventured into new traits such as biomass characterization. Biomass is an important trait for rice varieties, and before we didn't have an easy way of measuring it. It was very difficult. You had to sample it, and then you have to take the dry weight of that over a period of time and things like that. But now all of this can be done by a simple mobile-based app, which was developed by our colleagues from Japan. And this is a slide which indicates the kind of diversity that is available for rice in terms of the biomass. So in the table above, we can see many of the material have about only 1 ton per hectare biomass, but at the same time we also have about 10 ton per hectare biomass. So it's a wide range of variability. Before it was very difficult to characterize, but now it's very easy. But we are not happy there. Again, you have to go and take image of the variety in the field, but the same can be done by drone. And now we are kind of optimized the model that is needed to kind of extract the information about the biomass just by a drone flight. And so this is how our raw data looks. And but this is not yet completed, but we are almost there. Next, coming to what we call as a digital grain identifier. This is an in-house developed ML-based classification model where almost the whole collection in the gene banks, we have used that to train this model, and it can predict the accession just by looking at the seeds. So this was our raw data. And then how is this useful? We use it mainly for seed authentication. So in gene bank, seed authentication is an important step where we have to be sure that what we have is the original, correct, true to type, and there is no mixture or there is no mistakes in any of this, because we have to give the most original type of seeds to the user. So for this authentication, before it used to be manual, we used to compare the seeds against what we call a seed file. But now that can be done by AI-based model, and this is a model that was developed in-house, where it will tell you and give you an accuracy score of how true to type it is to its original. And based on this has a lot of other applications as well. So coming to the how AI can help us to better understand the collection. So this is one picture which I like, and I call it as a bird's eye view of the whole collection, where the seed morphology of the entire collection has been once digitized and the information has been extracted, and then the wide range in variation in the collection has been presented in terms of this figure. As you can see, there is tremendous variation, and the kind of differentiation that we are getting using this method is quite spectacular, and it almost like similar to what the level of differentiation that you can expect by high-density genotyping. This has a lot of other applications. Some we are yet to think of how do we use that information. Then it also helps us to understand the collection in terms of the variation within the sample. Here we are talking about variation between samples, but again, within variation in gene bank versus breeding, this is one main difference, where we expect a lot of variation within the sample. So how do we quantify that? Before it was almost not possible, but now there is a means to do that. We can say, okay, which accessions are highly variable, which accessions are highly uniform, using this information, which helps us to improve our operations and better handle those specific types. Then AI is also helping us to ask novel questions which we never thought was possible. For example, we have some accessions for which we don't know where they came from. And we can ask the question today and say, oh, where did this originate actually? So in this case, I take an example where a very famous Italian variety called Astiglia. The question was, people were saying, where did it originate? Of course, rice didn't originate in Italy, but somewhere this variety came from. So people have done extensive sequencing to find what is its true ancestry. And but we have shown that using AI-based method, which very easily you can actually kind of deduce its original location. So there are other applications to this as well. Then coming to data management and curation, today's it's the world of time of LLMs, and most of the time people in most gene banks, very few, only one or two database managers are there who will be helping the whole group to kind of interact with the database and get the information and tell them, and also to plan the activities. But now by connecting that database to an LLM model, things have become very easy. So this is already kind of happened in our gene bank. This is a very liberating experience and it's kind of democratizing the data available in the collection, in the database, for anybody to kind of interact and get the information, which helps us in planning. So this is happening. Then coming to the last part, I would say, which is about use. One of the criticism of the gene bank is gene banks are underutilized. Shalini mentioned about that, and this is a major complaint about gene bank. One of the reason is, how do we know what is good for what? And to do that to get that information, it's very expensive and very time consuming and laborious as well. So for this, we thought of a AI-based approach, which is expected to be faster and a very cost-effective approach compared to the conventional approach. And we have kind of tested this over with half of the collection, and I have some results to showcase. So this was based from a competitive Google grant that we received in 2023, which helped us to develop this methodology of developing an AI-based methodology to screen the large collection in a quick and cost-effective manner. So in simple, this is how the half of the collection looks like. Over 60,000 samples, which is about half of our collection, was taken, and we subjected them to screening for flood tolerance, for drought tolerance, and salinity. And the important varieties were actually that are very good for under these conditions were extracted. These materials are very useful for plant breeders and researchers for further work, and it's an important tool to fight for the climate change mitigation or adaptation breeding. So this is a summary of what we did using this AI-based methodology. If you can see a trait like flood tolerance, which I mentioned here, ever since the Erie Gene Bank started in 1977 till 2023, about 18,000 samples were screened. And but with this new AI-based methodology, within one season, we could screen almost more than 3 times of what was done in the last 40, 50 years. So that is the power of this methodology. And as I mentioned, we initially targeted flood tolerance, but we will also be able to do the same for drought tolerance and salinity as well. So this is I can say, a very, very major progress in our field with respect to the throughput that we were able to demonstrate. So with that, I would like to close, and this is my team and my collaborators and contributors for this work. With that, I would like to stop here, and Javu and Shalini, over to you, please.
Thank you so much, Venu, for this amazing presentation. I actually enjoy a lot when you speak, so it was great. And thank you so much for this. And then we really look forward if we have some overlapping areas wherein AI could actually contribute to some of the advancing studies that you showed, specifically with generative AI too. So thank you once again. And if there is any question, we'll be very happy to take it. Just one question, or maybe if there is a question online. Is it? Okay. Thank you so much, Venu. So we'll move to the next session, which is very interesting. And it is Artemis, which is AI-powered digital phenotyping for public breeding in Global South. This session will showcase the Tanzania-based Artemis project, an AI-powered digital phenotyping platform designed to enhance public breeding efforts in Global South significantly. So with this, I would be welcoming David. Leonard, Hannah, Stephen, Joanne from SIAT, and I hope I'm pronouncing it right, Gustavo, Simit, and Yangwa from Gates Foundation.
Thank you so much. So we have Gustavo and Jacob here, and not Hannah, but Violet. Thank you so much. So my name is Leonard Woltering. I'm Sustainable Innovation and Transformation Lead at the Alliance under the Digital Inclusion team. And I'm very happy to be standing here because I'm moderating and I'm not presenting today. So I think it's better for everyone. Artemis is on a mission to make digital technology available to the vulnerable people out there. And how are we going to do that? We're going to show you how we do that by having two presentations. Then we have two semi-external perspectives, and then we have a Q&A, time for Q&A as well. So without further ado, I'd like to hand over to David. David is very easy to introduce. He's Chief Mischief, and that's it. So David, take it away. Applause, applause, applause. Yes. Yeah, thanks, Leonard. So Leonard and I share an office. So if I'm Chief Mischief, he's assistant to the Chief Mischief. He's a mischief of mischief. So thanks a lot. We'll talk about Artemis, try to get through the slides here. So the whole premise around what we're doing is that plant breeding really relies on phenotyping as the core data collection process. And phenotyping is really based on human observations. And this has been the case since the dawn of agriculture thousands of years ago. People look at plants, they see what the plants are looking like, what the plants are growing, how they're growing in different environments. You choose and select the ones that are looking the best or performing the best based on criteria, and you move those into the next generation. So human observation is highly error prone. We all know that, and it's based on qualitative estimates at best. So we were talking to a bunch of breeders, and breeders are saying, yeah, we know that there's problems in phenotyping, but it's what we have, and there's not much more we can do. And so, given the complexities of choosing parents and then crossing parents and evaluating the progeny, it sometimes can be a bit like the lottery. You never know which genes are going to be transferred, if those genes that are transferred are going to be the ones that you really want. So we wanted to kind of measure this and really assess whether these assumptions that human-based phenotyping are actually valid or not valid. And so we took some plots and we're measuring with beams plant stands. So how many plants have come out of the ground and emerged and now are visible. And so we took a bunch of, and this is an image of what you would see in the plants in the field for plant stand. And we can clearly, count, how many plants are there, pretty visible. But then if you wanted to do this across whole plots, what does that look like? And so we measured this. And so on the left-hand side, on the right-hand side are two different days of observations, 2 days apart. Each of the bars and the colors represent an individual plot. And within those bars and colors are different people measuring the same thing. And so what we're seeing is that even something as simple as plant stand, humans are just really bad at doing it. There's a lot of error associated with even very simple processes. And so that's plants that you can imagine something more complicated like pod counting or flower counting or something that's really, really, really difficult. The errors are just going to be magnified. So breeders understand that this is an issue. We know that it's an issue. And so the whole premise is how can we solve this using computer vision and other types of machine learning? So then we do know that computers and other approaches are very useful for counting things and for measuring things the same way, the same time, no matter where you are. They can count things that people aren't really good at counting. And so the premise there is, can we look at developing sort of computer vision-based phenotyping that could help to solve some of these issues that we've been seeing and measuring with the human observations? So we wanted to target smartphones. So there's been a lot of presentations today about how this could be used for drones, how this could be used for robotics. These are fantastic, right? Really, really powerful tools that are really mature and deployed at the commercial scale, but they're really deployed in large breeding operations, right? So thousands of hectares on centralized breeding stations across the CGIAR and beyond. But what about the people on the ground at the NARS who are based in remote rural parts of Africa or Asia or Latin America who don't have access to advanced technologies? Well, now we know that smartphones are basically everywhere. Maybe not smallholder farmers have them, but certainly breeding technicians and breeders all over the world, no matter where you are, do have them. So we believe that this is a scalable technology and it's relatively affordable. Rather than spending thousands of dollars on a drone, you can spend a couple $100 on a smartphone. But there were some challenges, right? The different smartphones have different, technical specifications, and maybe throughput efficiency of wanting to bend over and measure some plants may be a bit challenging. So we knew there was a potential solution, but also there were some potential challenges that we wanted to address. So we started out by looking at creating just basic handheld smartphone approaches. And it was working pretty good for measuring things like plant stand, but then a lot of really interesting plant parts are held underneath the canopy. So in beans, for instance, you have flowers and pods and all these interesting things are underneath the canopy, which drones can't see from above. But a human with a smartphone can come over and lift it up and can take a picture. So that's good, but the problem that we had is that taking manual images with smartphones really, really sucks. So you're bending over in the hot sun with your back for hours and hours and hours at a time, and it's worse than taking pictures, worse on your body than going through and doing manually phenotyping. So this was problematic. So we were thinking through what are some of the solutions that we can use that are still viable for some of our breeding programs, let's say in Eastern Congo, who are breeding beans for millions of people in very vulnerable communities. So what are some of the solutions that we can use that can be deployed in those types of environments? And so we thought, okay, what about a small little push cart? You get a couple pieces of metal that you can get from a bicycle, a welding torch, a little wheel, you mount some phones in it, you push it to the field, maybe you can take some photos faster. So we did some quick iterations, and if any of you know Google's R&D division X, they call this version V0 crap. So it's the version 0 and it's crap, but it provides directionality about where you can go in the future with different versions in order to create something that's more viable. So we went from V0 crap to something that's more of like a V1 less crappy, to a V6 that's even less crappy, to a version which we could then showcase to the Gates Foundation and say, look at what we're doing cool stuff, to something that's now V9 and is working pretty good. So same basic technology, a piece of metal, a wheel, and a welding torch, something that's working quite well. And along the way, we threw a bunch of stuff in the trash because it wasn't good. And so this is kind of like this frugal innovation process. How can we use high tech and low tech, combine them together, that's really well adapted to the environments that we need to serve within the CGIAR and the Global South. So then we measured some of the outputs. Okay, we think we can measure it faster with the smartphones, but actually can we? So again, back to the visual phenotyping, people looking at plants in the ground, how long are they taking? On average, they're taking 1 to 2 minutes per plot. So when we use that really sucky part about bending over and taking a picture, then we're seeing that you're anywhere from 2 minutes to 5 minutes per plot. So not scalable if you're working across thousands of plots across multiple breeding centers, across multiple countries and multiple locations. So then we use that phenocart, which we're calling Bruno, and there's a very interesting story about why we're calling it Bruno. We can talk to it later during tea time. But using Bruno, we're finding that we can measure the entire plot for 30 seconds or less. So that's one plot, every plant, every flower, every pod, every field, 30 seconds. So we're really like improving efficiency and accuracy of what we're doing. So then we're looking at the model performance, and what we're seeing with model performance is that if you get good images with decent models, you can get pretty good accuracy on some of these model outputs. So with beans, for instance, we're getting good models for relatively small amounts of imagery, annotated imagery. With something like sorghum, we're getting more imagery is required for producing less accuracy, but relatively good accuracy still. And it's, the adage is if a human eye can see it well, then a machine can probably see it well. So human eyes can see the beans pretty well, and human eyes can see the sorghum a little less well. Same thing for computer vision. And so we're seeing that our assumptions that we have based on human vision is really following through to some of the computer vision applications. And so when we look at even harder challenges, it's not transferring over. Interesting. Internet connection is unstable. Not much you can do about that. Sure. Okay, here we go. Okay, so cowpeas and common beans looking at pods. Pods are a much difficult structure to be able to visualize, either from a human or from a machine. And so we're seeing that we require more images and the accuracy goes down a little bit. And that's because we're seeing a lot of occlusion, right? Pods are behind other pods, behind flowers, behind other plants, or some of the peduncles for cowpeas are looking a lot like pods for cowpeas. And so the different approaches with different plants, different traits, different parts require different modeling approaches and different approaches to the imagery annotation. So about imagery annotation, so how does that process look? Well, when you look at annotated imaging, internet issue again, is it coming? Let's see. Sorry, folks. Yeah, I really have to wait for the image here, unfortunately. Computer vision images important. Gone. No signal. It looks good on my screen, so I don't know. I always find it's funny. There we go. Okay. Tech problems at a tech presentation, so it's ironic. Okay, so to produce those models, we need to have annotated images. And so we were saying, okay, we can produce good models for relatively few annotations, a couple of hundred to less than 1,000. Well, this is what an annotated image would look like. And this is for segmentation models where we're segmenting every different types of the plant parts. One image, annotating this one image takes between 10 and 20 hours, right? So it's a very, very big lift to get a very accurate model. So it's a very cumbersome process, and I think the numbers of how many images are really mistaking how the effort that's required in order to build some of these models. And so in order to do that, imagine if we get across the CGIAR, we've got a dozen crops, we've got a dozen traits, and each trait has a bunch of different parameters that we want to look through. So if you multiply these together, then you're talking about really a high amount of effort that's required in order to make deployable models. So we're partnering with a couple of firms that we have a very small army of about 50 annotators in the Philippines that are full-time. Their job, Monday through Friday, 8 a.m. to 5 p.m. is going to be annotating these images in order to build these models. So AI works if you have the right images. Right images require good innovations in the field to collect, and they require a lot of work to be able to manually annotate things. So it's not as easy. AI already did it. AI already did it. Well, AI already did it is really, really hard. So this is showing some of our model outputs. And so, I don't want to get bogged in the details here, but what we're seeing is that on the x-axis, all the different numbers and letters are basically combinations of traits and plants and methods to collect the images. And so the colors and the bars, we're seeing that these are different modeling approaches that we're taking. So not all models are the same. Not one model would work for every type of plant, every type of trait. So you really need to think about your modeling approach has to be really fit for purpose. And so putting all this together into a deployable package for smartphone phenotyping applications is really hard. And it may look easy, but it certainly is not. And all of this technology is changing every day, right? The models that we used 2 years ago are totally different from the modeling architecture that we're using today. And so then as kind of wrapping up what we've done, we want to really think about, well, what is the purpose of technology? Right. So a friend of mine, Willie Moo, who always talks about computer science and computers, right? Computer science is not about the computer. It's about what you do with it, right? Like biology is not about the microscope, but it's about what you do with it, right? So AI is not about the AI, it's what do you do with it? And so what we want to do with it is we want to think, okay, we as the organization want to look at big problems, right? Food security, poverty, malnutrition. And we want to think about who are we going that for? We're doing it for smallholder farmers and the challenges that they have. So what we think about AI and technology is really how do we bridge those pieces together? How can we use technology in order to link sort of the global problems with sort of the solutions for the people that we need the solutions for? And so it's really fit for purpose. And the purpose in this case is global development. And so the way that we're approaching how we derive our assessments and our theories and our processes within our program is, okay, we want to be able to use technology to bridge the gap between the global problems and the solutions to target users. And our first use case for these technologies is then breeding programs, knowing that the breeding programs are providing varieties that are directly applicable to smaller farmers. They're having a lot of vision issues that we can potentially solve with a bunch of crops. It's really hard, but at least this is a concrete place where we can start. So from there, then we dedicated really about the people. So we talk about AI a lot, technology, digital, but it's really people-based. So we have people and partnerships. That's what's required in order to make things successful. So we have a dedicated team. We have partners that are working between computer science, human-centered design, data science, and also plant breeding. So super, super critical. And for there, we're looking at tech stacks. So as we're building sort of these solutions, we're building a bunch of tech stacks that include images, image annotation, models, model libraries. All these things can be serviced as global public goods to people that can be using it for what we're doing, but also from beyond what we're doing. And then in the end, we want to be able to translate just the interesting tech and the interesting data and interesting science into actual products that can be delivered to be able to provide goods and services to the people that we need it the most. And so one of the things that I think we want to do as a team and that we want to be pushing other people to think through is how can you take your ideas, how can you talk about AI and technology, and how can you actually deliver products and services, right? That's a big gap here that we need to be able to bridge to move from problems, solutions, to deployable technologies. So a bit of a preview for the next round of presentations is that we've been talking about taking images of smartphones. But some of our colleagues here are also looking at different branches of AI. How can you use voice and speech and other stuff to be able to glean from our insights, and how we can put that together into some sort of multimodal model. And so all this package here that we're talking about right now, and that this slide is representing, is in collaboration with Google Research. So Aisha and colleagues who spoke today are one of our key tech partners that are looking at developing some of these multimodal foundation models that can be used for doing a lot of different really cool things, good applications. And so the outcome that we're hoping for is better data, for better breeding decisions, for better products that can serve markets that farmers need to be serving. All right, that's it for me, Leonard.
Exactly 15 minutes. I'm really impressed. So while Steve and Violet are coming up, I have a question to you. Who has done surveys or interviews with many farmers? Can you raise your hand? Is that easy or difficult? Somebody wants to just take the mic and... Peter, easy or difficult? Yeah, I'm looking at you.
Yeah, some would say it's easy. It's really easy to get an answer. It's very difficult to get a good answer.
Anybody else? Who else has experience with doing a lot of, reaching out to a lot of farmers, doing interviews, surveys? Satish, you also had your hand up. I saw it. Aha, I'll give you the mic. Easy, difficult? Oh yeah, there you go.
It depends. If it's well planned and well executed, it is doable. I'm not saying it's easy, it's doable.
Okay, great.
But it's not difficult as well.
Sorry?
It's not difficult as well. It's doable, but it's not difficult as well.
Okay, great. Okay, let's move on. Thank you so much for that spontaneous answer. So we have here Steve Mutuvi. He's an AI engineer with the Alliance. And we have Violet Lasdun, PhD candidate at the London School of Economics. And the floor is yours. You have 20 minutes. You want the microphone?
Okay, thank you so much. I'll just dive into the presentation. David has talked a lot about computer vision, but we also do, other types of speech recognition and natural language processing. And today, at this point, I present that together with my colleague Violet, who will take us through some use case to see how this data findings looks like. So generally, it's very difficult to extract data from rural communities because of obvious challenges related to infrastructure, literacy levels. But collecting this data is very important and essential for research, particularly towards global development. So we must find ways of getting that data and supercharging the service that most of us agree as scientists to use to collect data. So we are looking at ways to enhance that process and make it possible to collect this important data that is available in those communities. For us to do this, we have been working on techniques, focusing on listening to farmers. It's very important to listen to them, gather feedback from them. And just to talk about the example of breeding, it's not just enough to develop varieties and hand them over to farmers. It's important to get to hear their preferences, what they say about those varieties. And this information can really be useful in developing varieties that are adaptable to the local needs of those farmers. And so we are leveraging speech recognition techniques using state-of-the-art automatic speech recognition models to transcribe large volumes of audio data to text, which usually would be very challenging without such techniques. And then after doing that transcription, we go ahead to do analysis. And in this case, we are leveraging large language models with just prompting. So it is quite challenging to build labels to train models. So we are trying to alleviate that by doing prompting, and we are finding quite good results, as we shall see in our use case a little bit later. What is unique with this form of data collection? So one of the important things to note is that this is speech data through open-ended conversations. And so you can be able to capture farmers' response through their local language, going to details that probably surveys may not be able to give you because of their structured nature, their predefined categories that already make assumptions of the kind of responses that farmers would give. But through these techniques, we can have opinions organically evolve out of the data, facts come out of the data, rather than being confined to predefined classes. Another advantage is the inclusive nature of this work. You don't need to be able to write to get your opinions heard. You can just speak them out. So this overcomes the literacy barriers. At the same time, you can be able to provide additional information that goes beyond just yes or no responses. And most importantly, the work helps us become more inclusive and also be able to scale quite easily, because you just record and transcribe and then the analysis is done in an automated way. I need to talk a bit about what happens in terms of the steps that we take to do the processing. As I mentioned, we are doing a transcription using a service. We have used a Whisper model. For some of us who might have done a bit of model training, you will realize that Whisper is quite good, especially for low resource languages like Swahili. We started working with the Swahili audios, of course, planning to scale to other languages. And after that, then, as I mentioned, we performed prompting. Initially, we did some classical NLP where we fine-tuned some models to perform aspect-based sentiment analysis, which usually will pick the opinion, the sentiments, and besides that, we also looked at emotions, because the richness of this information allows us to know how the farmers express themselves, and therefore pick the emotions besides the sentiments that they expressed. But at the end of this, we want to put this together into a product, and we are calling this product CGIAR in line with listening. So CGIAR is a Swahili word for listening. So we want to have a product that allows researchers to listen to farmers, for example, But this is not limited to farmers. It can be any interviewees that you are targeting in your research. So that's the goal, and we plan to continue working on this to improve and add more features. I will invite Violet to talk about a use case on farm breeding, because this is where such technologies can really have a lot of impact. Thank you.
Cool. Thanks, Steve. Cool. So I've been doing a lot of work on this kind of first use case, which I'll tell you about in just a minute. But first, to zoom out, the kind of overarching problem that we're trying to address here is that traditional data collection methods can face this trade-off between depth and breadth, right? So depth, nuance, the details that you're getting versus the breadth and scalability, how many people can you actually reach? So on the one hand, something like an interview or other more high contact methods like workshops, demonstration plots, these are great because you're face-to-face with people, you're able to listen, hear about the problems people may be facing, solutions they may be generating. But these are very difficult to scale. So you often end up with a handful of participants, people who are based closer to research stations, easier to access, with sort of pre-existing affiliations, maybe with the research program, with the researcher. And these individuals may not be fully representative of the wider population. So maybe you then try to kind of take those insights and use them to develop more structured survey tools like multiple choice, it's kind of surveys. And that's obviously great in terms of scalability, but it requires that you know what you're looking for, what you're trying to ask. And that may not always be the case, right? So structured survey tools impose a kind of top-down assumptions, right? You're sorting people into predefined categories. And sometimes people may have something to tell you that you don't know to ask for, and those insights will be missed. So what we have is these more scalable survey methods, miss kind of the specificity, the nuance, individuality of responses. And when you combine that fact with what Steve was talking about earlier, which is that it's often the most vulnerable, marginalized populations that are excluded from these more high contact research activities, then we see why the data sets that we end up with and the policy decisions that are taken from them often fail to adequately represent these groups. So within DZ Project, we've been kind of working on methods to address that gap, to kind of overcome that breadth-depth trade-off. And the CGIAR product, our aim is to empower researchers to collect interview quality insights at scale for any research question, any domain. So with that in mind, I'll give an overview of the first use case. And hopefully these details will provide an illustration of what we kind of imagine for the impact and potential of these approaches, kind of a paradigm shift in the way that we collect data, or collect and process. So the application is in the context of on-farm breeding, in particular participatory variety selection, which many people in this room are probably familiar with. These are processes for incorporating farmer feedback within breeding processes, from the development of target product profiles to evaluating varieties on station and on farm. So this familiar problem, this gap between research and reality, crops are developed largely on stations in kind of controlled environments with constant inputs, relatively uniform conditions, and somewhat narrow breeding goals like maximum yield potential. So when these seeds or varieties go out into farmer production environments, they often fail for two broad reasons. One, they may not perform well in farmer production environments because it's so different from the research station. But second, even when they do perform well, they may still not be popular, may not be adopted if they fail to meet farmers' priorities, preferences, things like consumption preferences, taste, cooking time, but also agronomic compatibility, right? So do they work well in an intercropping system? Do they require additional labor and drudgery? Do they require complementary inputs that farmers don't have access to? So getting to the bottom of what farmers actually care about when they're deciding to choose which varieties to grow is really critical, getting that information back to breeders important for the development of successful varieties. So PBS methods are all about closing that feedback loop between farmers and breeders. And there's many incredible creative ways of doing this, but we definitely still see this depth-breadth trade-off, where some methods focus on getting really individualized, personal, conversational feedback from sort of a few farmers in a in-person workshop type of setting, while other methods focus on decentralized data collection from many using more structured survey tools. So this was the perfect use case for Indizi, which again tries to bridge that depth-breadth gap and do both, right? Score high on both of those axes. So to do that, we set up this trial in Tanzania with Common Bean. We worked with 480 farmers and used the tricot methodology, which maybe you're familiar with, which allows farmers to grow and compare 3 varieties in small trial plots on their own farm. So it's an amazing method for running decentralized variety trials. We set up the trial in 40 villages across that were randomly selected to represent kind of major bean growing agroecologies in Tanzania. And we went to villages that even the village leaders would say, like, this village you can't run surveys here because you can't access it during the rains. We said, it's okay, because we have a plan for this. These places are underrepresented in data sets, and we want to overcome that. That's the entire point of this method. So what we did was hire enumerators, data collectors, locally within each of those villages. We focused on youth who are savvy, comfortable using smartphones, and this was really key to running this highly decentralized, inclusive trial, because we were able to get this high-quality data directly from farmer fields throughout the entire growing season, no matter the weather, no matter the conditions of the road, and without having to just kind of send people back and forth. So the enumerators did a fantastic job. They collected open-ended responses, like Steve was describing, at several points throughout the season, asking farmers what they like and dislike about the varieties. Farmers were able to respond in their own words, in their own terms. And yeah, so then we got all this amazing information. The next step was to process it. So first we transcribed the speech into text using an ASR model fine-tuned for Swahili, which already saved having to manually transcribe over 40 hours of data, which anyone who's ever tried to transcribe an interview by hand knows is like extremely tedious. So already a huge win. Then after that, the next step was to identify the parts of speech in which the farmer was describing the variety, because for our particular research question, that's what we cared about. So that's these highlighted chunks of text here, which we refer to as the opinions. And after that, it was to classify those into positive or negative, whether that opinion is a positive thing, a favorable thing about the variety, or an unfavorable thing. And we did all of this just by prompting LLMs. So there was no fine-tuning of models. There was no kind of recognition of words like older classical style of NLP that's really restrictive in what it can do. This is all just basically like asking ChatGPT to look at your data, essentially, in a more advanced way. And what's really cool about LLMs, besides their flexibility to really address any research question, is that they are able to take into account the entire meaning, the entire context, like in the way a human would. So something like pods matured unevenly, this trait might be a positive thing for some cases if, for example, that provides food security throughout the season. But in this case, you reading it can see, I didn't like that the pods matured unevenly, it's clearly negative. And the LLM is able to kind of work in that same way with the semantic meaning of the entire phrase. So you can see for traits like seed color, size, plant height, a lot of these characteristics might be positive or negative depending on the individual, depending on the variety. And you really miss a lot of that nuance with traditional data collection methods and even with classical NLP, natural language processing. So what can we actually do with this data? And what can we do to enhance PBS? So first, for trait discovery, understanding what farmers are actually noticing when they're looking at or evaluating their varieties. And second, trait prioritization, so which traits are most important to different groups. These two things are super important for any kind of market research, understanding why farmers make the adoption choices they do and getting that information back to breeders so they can select for those things that really matter. And third, we can do variety evaluation. So as I mentioned, we ran these interviews in the context of a variety trial. So we know exactly what variety is being described. So we can see, okay, how are farmers describing these varieties? What do they like and dislike about it? So we're able to really look at that through the farmer's perspective. So in terms of trait discovery, we used OpenAI's embedding model. This gets a bit technical on the slide, but I will explain it as best I can. To convert those farmer opinions into semantic vector representations. And then we used a dimension reduction technique to kind of plot the set of all of those opinions in two-dimensional space, which is what you see here. And then we used a density-based clustering algorithm to identify the kind of groups of semantically similar opinions. Right, so in more plain English, this is called topic modeling because it's identifying the latent topics that are present there within all of these audios. So each of these points is one thing that a farmer said. So remember we saw before the highlighted text. So you're seeing these opinions here too. So these are just like direct phrases from the farmer. And where they're mapped in the space is just based on being close to each other. So this brown cluster here we called taste and cooking quality. And it includes things like, I like the taste was sweet. And then maybe a bit farther over, it cooked quickly. I like the taste after cooking, right? So the closer in meaning to opinions are, the closer they will fall in this plot. So basically, it's a AI technique that just does what a human would do if you were to like classify each thing close to each other. It's not looking at how many words are repeated together. So things that mean the same thing but are phrased differently will still fall close to each other here. So super cool way of looking at speech data and pretty recent that we're able to do this kind of analysis. So yeah, this allows us to see kind of what broad topics are of interest to farmers, as well as to dive deeper into each topic and see what specific factors people are looking at. So instead of just say having like it had good plant vigor, we can actually dive into that and see the leaves were wide, the plant grew quickly, the vines were strong, right? To see these specific things which may be more actionable for breeders. So once we have that data set, we can then do a lot of analyses using those kind of cluster names that emerged organically from what farmers were saying. We can then kind of look at things like which of these clusters was said the most. So here we can see like yield was mentioned the most in general, and then we can also break this down by any demographic factor. So here it's broken down by gender. You can see like agronomic traits like yield and climate tolerance are mentioned more by men, while taste and cooking quality is mentioned more by women. And that might not be blowing anyone's mind, but it's kind of a nice intuition check that these methods are making sense, right? And then we can dive and use them to find more surprising findings as well. We can also look at the structure, like how people talk. So kind of the metadata, speech patterns, the way of describing the same trait. I think in one of the earlier presentations, I heard about how it's interesting to see like people have different words for things in different locations, maybe describing the same thing. So we can look into a lot of that. Here I've just presented one kind of fun finding for you guys. We can see who's chattier in terms of who has the most chatter around relative to the number of opinions we actually get out of that data. So I don't know if anyone wants to guess which group is chattier. I hear men over here. And in fact, men were chattier. Women were more efficient at getting their point across. And finally, we can use the same those categories that emerge naturally from the farmer's own words. These same categories, we can use them to evaluate the varieties in a trial, which is something I've heard from a lot of breeders. Is something they try to do. Like breeders are trained to look at crops in a certain way, but they maybe want to see how farmers are looking at that so that they can actually make decisions that have outcomes that are correct for farmers. So here we've evaluated all these varieties. This is just a small example, and we found that they're quite in line with what people tell us what breeders know. So again, a nice intuition check on this method. And yeah, so that's kind of the summary here. And you can see that taken together, these really represent a new way of doing PBS, a new way of really listening to farmers' feedback and capturing critical insights that they may have. And hopefully you can also imagine how these innovations could extend to any research question, any domain, health, education, market research. Yeah, cool. Thank you so much. And I give back to Steve for some final remarks.
Thank you so much. And as I finalize, as I said earlier, the goal is just to build a product that allows researchers to go from audio input into actionable insights, and with the flexibility that they need in order to answer their research questions. Of course, a very important thing that I need to mention is all this will have a multimodal integration. For example, if a farmer says they see some sort of diseases in their farms, they can be asked by the LLM or the chatbot to take some pictures, and all this can really enrich the analysis. Thank you so much.
Yeah, thank you so much, Steve. You're welcome to sit there, and then you can stay seated. And I'm asking Jacob and Gustavo to provide some external perspectives. And I'll start with Jacob van Etten. I think I'm the only one who pronounces it correctly at this conference. To provide, you can sit here, yeah. To provide a bit of a helicopter view about what we just heard, right? I think you can speak through the mic unless you want to.
Yes, okay. Yeah, great. So we have two presentations, one about our domains like phenotyping visual, and another presentation about speech to text, both AI techniques. Really taking a look at a very old area in the CG, right? The CG started as almost like a breeding organization, and really taking a fresh look from the eye of these new technologies. What can we do with it? And also from this perspective of taking it closer to the actual environments where the breeding has an impact. The people, the fields, getting it out there. And that I find the exciting bit of this, right? It's not trying to create ideal conditions for our genotypes, so we really see how nicely they look and how different they are. But it's really taking our science into the context where it matters and trying to get as much information about that. And I think that is one of the big interesting things about AI, doing the science, but in the wild, right? So for example, in psychology, you do experiments in labs with people, social psychology, and you extrapolated what do people actually do in supermarkets, zero correlation. In breeding, sometimes some of that happens as well. So this is really adding value to our breeding operations. And what is the other thing that I think is a common denominator of this research, that in the end, as David also says, doing AI, it's not about the AI itself. Right? Biology is not about a microscope. And so a lot of the work is actually about making a pushcart. Right? It doesn't sound very sexy that CG has done 2 years of work to produce a pushcart, but that was what was needed to get these processes going so that you really get this cycle going. Right? And so you do a lot of work that doesn't sound sexy, such as making a pushcart, making SOPs, standardizing data, agreeing about that, and all these things. Yet AI is about that as well. And I think that's really important to keep in mind, that the AI is not only sitting behind the desk, but it's actually getting the 4x4 stuck in the net. Because that's where the AI really makes a difference when we take it to the field, and that's the great potential of AI to get it. I think there's like immediate relevance of this research. I'm looking at Peter here, for example. If we get farmers to talk about the crops, we get insights that we would not get if we send out people with questionnaires with closed questions. So we can get surprises from the data, things that we didn't know about new traits or new uses of a crop. I have experienced it myself. In Costa Rica, for example, we had a variety of beans that we thought was fantastic. Farmers picked another one, which was very early, and why? Well, this one, it's low yielding, but actually it's very quick. and I can grow onions after that, and then the onions are ready just before Christmas when the onion price is very high. And if you calculate like dollars per hectare, this variety is much better than this high-yielding bean variety. Take that back. And actually, they changed the release decision in that trial, and they released that variety. So you really get these kind of contextual insights with AI from that you wouldn't expect, the surprises, when you really go for this. And we talked about it already. I think doing very good qualitative research is super difficult, actually. And I think that's where AI now is helping, right? And transcribing interviews is not only tedious, then interpretation is also difficult. And I think we can do a lot to increase qualitative skills, helps with AI, but also supported by AI. And learning languages using AI, I think we can also train people to do very good interviews using AI, right? Like what should be the next question I should be asking now? You can train people even before going to the fields in these kinds of things. I think there's great opportunities, I think, to broaden the work. And we already talked about it over lunch, for this one, for example. And I think that will also have this much broader impact. If we know what farmers need, what their pain points are, we can really rethink what we're going to do in breeding and think about breakthrough products, for example, that really address new kinds of challenges that we didn't know about or that we didn't really address enough. And now we have the data to justify those kinds of investments, to go to the investor and say, look, actually, we don't need higher yielding bean varieties in this place. We need quicker ones because then people can grow onions, for example. Then I think there's a lot of scope to like broaden it to other crops, integrating the different tools that we have on farm testing, on the things that we're building on market intelligence and phenotyping and qualitative research to get kind of an ecosystem of tools that talks to each other and that can transform the way that we do breeding to have a much higher impact and to get full potential from all the bioscience capacity that we have in the CG. So I'm really excited, and I hope we keep investing in this area with this kind of perspective. Thank you very much.
Okay, thank you so much, Jacob. AI in the Wild. I think it's a great title of an article. So Gustavo, thank you so much. Gustavo is a global shared services leader for the CGIAR breeding resources, and he's also working a lot with tools and technologies around phenotyping. Thank you so much. The floor is yours.
Can you hear me okay? Yeah, very good. Okay, so no, it's really good to see this progress, Leonard. So I joined CGIAR in 2018, and since then we've been discussing about how, when, and how that would be, and when CG would really adopt modern digital phenotyping tools. The most important thing to consider is why we need that. We need that to develop variety faster, cheaper, and more varieties to the farmers. I think that since this 2018, because we've seen many improvements in CG and the national programs, in many improvements in many different areas. Since, well, as Jacob said, in how they defined market intelligence capacity, and goes out even also how breeding teams itself they manage their breeding programs. I think that now CG and NARS much more mature and more prepared to receive things that they were not before. I mean, even that if we had those tools years ago, probably wouldn't be useful because we didn't have the protocols or processes beyond the phenotype that would allow them to develop good data. So now I think that many more are more prepared to use the tools that are developed. And I would say also that now is the moment for that because of they are prepared. Of course, there are many levels, and maybe there are some that is not there, but there are many that are really prepared and need that. Need that because we need to standardize data. And we really need to make our data process and data collection cheaper, because it's one of the most expensive process for breeding. And we need to attract a new generation. So it doesn't make any sense to talk about, we need to lead by example. We cannot really imagine that we will attract young scientists by providing them a paper to go to the field and take notes. I mean, of course, that needs to come together. No? I think that for us in breeding resource, what we do is facilitate the access for tools, from genotyping tools, from phenotyping tools and services, to all the CG and partners breeding programs. I believe that, as I said, now is the moment for all those things. Is the momentum. Many they are ready. It's a matter for CG to really think on how to prioritize, how to really get to the things that would be the game changer. So how to get to the point where we really use the tools and develop the tools that really add value. Right? Those are where we will make the difference. And I think that Artemis and all the Artemis project, everything that was presented today is really appealing to that. I think that you're going to the right direction, and yeah, things will be different in a few years. I really believe that all the variety development will be fully adopting digital phenotyping tools in a completely different way. Not only in the on-farm trials, or that is definitely one thing that would be growing, but also in research stations, and all those ecosystems will be completely different, and many of that because of those tools that is being developing. Thank you.
Thank you so much, Gustavo. I'm going to take time for 2-3 questions. And you already see why he's called Chief Mischief, because he's not sitting there. I noticed already. Yeah, go ahead, Peter.
Yeah, one question, one comment. The question is about, Stephen, I already saw the presentation you gave last time, so my mouth dropped open. I just looked at it, amazing. The visual you showed about those different criteria, beautiful. I think one of the things I would love to know right now, and I think which is super important, how long did it take to do that whole analysis? How much data went into this? And if you would do this again for another crop, another system, how much time would this take? Because I think if you tell that, it's even more unbelievable.
So we had about 6,000 of those opinions that went into that semantic embedding model. I just learned what semantic embeddings are about 3 weeks ago and did this entire analysis in about a week and a half. So it's quick. We've been working obviously on many different iterations of how to run like fine-tuned models and more classical NLP. So it's been kind of a learning journey, but the actual implementation to get all of these outputs was quite straightforward. And I'm super excited to be running this on new data sets. So I was just talking to Jakob about running the same analysis on the set of, so in tricot trials, they often ask like why after you have done all those ranking activities. So I'm gonna run the same analysis on those, and it will take a day or two because it's maybe one day, and then to extend it to more different research questions, maybe a week or so. But the goal is to really streamline that end-to-end process.
Maybe to follow up on that, I think what's amazing with all this work is like the speed how you can link quantitative genetics to farmers' opinions. You can right now really easy start to see what breeders are focusing on through these TPPs, these market segments, and directly test these new IDs, make that translation from a product to what a farmer will get feedback instantly, and see how you feed that back. So I think the cost and the efficiency of on-farm research, and also from a social science point of view, can drastically change, because we cannot forget how expensive and difficult that is. That's one of the biggest problems still in the global south. So like these innovations, I think, will be kind of game-changing in the next few years also on that side. as you were saying as well on phenotyping, we see the same on social science. So yeah, it's really impressive. So thanks for showing.
Okay.
Thanks.
Thanks, Peter. But when I asked you before, you said it's easy. Now you say it's difficult. Fantastic. Next one, and then in the back there.
So I'm going to come back to your easy, difficult question. I would have said very difficult. I'm an agronomist. I'm not a breeder. Agronomists have this tendency, for better or worse, to have massive surveys.
Yeah.
Really large surveys. They don't. I don't think they need to be that big always. There's a sense of, okay, we're going to the farmer, so we're going to just ask the hell out of everything to them. I think we could stand to be really more critical, but they're always going to be longer than the breeding applications, because we're talking about management. We're talking about a different kind of thing. Now, I should have prefaced this by saying a big congratulations to you all. I was blown away by this session. I'm so glad I'm here. And I will be following up on several pieces of it. Well, my question is this, that given that we're talking about these longer surveys, I would absolutely love to be able to do much of that, use that voice recognition and save all of that time and pain that it takes to extract the data, standardize it, do la with it before you can get anything. It takes months to do that. Hence my difficult. So what can you tell me about that? What is have you a sense of I would actually like to be one of the use cases if I can convince my friends in sustainable farming program to do this, to try and apply. What's your sense?
So two answers for that. First, one of the things that we're working on, Steve and I, for the next phase of this project is to work on more semi-structured interviews where AI actually assists in the prompting of follow-up questions. So this one was very simple, right? We just asked one open-ended question essentially. But to make this have the full impact, we really want to be able to run kind of surveys essentially. Or interviews. So that's one answer. It's something that we're definitely working on, and we're already going to try a use case. It's going on in the current trial where we're asking kind of follow-up questions about disease. So if people indicate that there's a disease, we then ask them to describe that, and also taking pictures and adding that modality as well. My second answer is that it's important to keep in mind when this is actually useful and when a survey is better. So certain questions are really quick to answer on a survey, right? Like, what's your age? I don't know, gender, like these things, they're quick. The advantage here is when you want to capture nuance. So something like in a survey, for example, in agronomic surveys or something, you might want to capture all the income sources of the farmer. And these are so tedious in surveys, right? You have to kind of check box, okay, did you have cows? Like how many cows? How many times a week did you milk them? Like all of that. And then at the end of the day, you still might miss something if you're not anticipating all the possible income flows. So to instead have a sort of structured conversation about the sources of income and about how you kind of prioritize your farm activities, and then to use that to kind of classify different farmer types for whatever profiling you want to be doing. That's an example where this would come into play. So to just keep in mind what works in a survey and what doesn't. And same with the tri-cut ranking. It's so great for getting a complete set of varieties ranked on all of those things. Like ranking is fast, it's efficient. This is not going to replace it. It's a different thing, and it gets at like more personal, individualized responses.
Thanks, great. The gentleman in the front.
Okay, so my question comes from a point of curiosity. The first question is because we're using the information from these data sets to make information. What measures are we putting in place to mitigate the eventuality of AI hallucination? Because if we are using these, we need to have accurate answers, and we don't need answers that have hallucination with them. And the second question, I was asking for the Swahili transcription in a context of East Africa. Yes, we speak Swahili, but we are affected by various dialects. So at that point where we are getting this data, how sure are we that the data we are getting is rightfully being transcribed to what it really meant, not what the AI thinks it meant? Yeah.
Great. Well, we have an expert on hallucination and Swahili. So, Steve.
Those are great questions. I think hallucination is generally a big problem to many models that we have LLMs at the moment. But one way we managed this was by ensuring that our prompt was tight enough by ensuring some few short examples. By few short, I mean, as we did the prompts, we had to give it examples of what we expect. And of course, we add some ground truth data, which we computed metrics against just to see how the performance was. And we had very high scores, above 85 in terms of F1 score, which was really nice. So I think you must have some ground truth initially as you train your models to calibrate them and ensure that the performance is good. And of course, as the models improve, I think we are going to see the hallucination issues become less and less. The second question was about Swahili. Yes, indeed, dialects is a major issue. We did this survey in Tanzania, where Swahili is better than here in Kenya, unfortunately. So definitely for you to be able to achieve that, you need more training data. And I must say that for the automatic speech recognition, unfortunately, you have to prepare some training examples, probably 500 to 1,000, which can go into training of those, fine-tuning of those models. And therefore, if you are to mitigate that, you may need to have data for the different dialects in your training examples for the models to work. But at least from our studies, we see that the models were good enough such that the analysis done by the LLMs was able to give out some good insights. So generally, I think it's hard. Swahili is one of the low resource languages that is fairly challenging, but I know there are other harder languages to deal with. So that's an area that probably more research is needed to get better results.
Excellent, thanks. We have time for one more question. There, the lady there.
Hello, I'm Fardosa. My question is, I just want to understand, in a context of a Kenyan, as a farmer, you find that we've talked, in the meeting, they've talked about hyper localization, where now they're trying to bridge that between researchers and the realities on the ground. You find in some cultural aspects, in some places in Kenya, land is traditional. There are traditional, there's informal land tenure system, and they're based on traditional. So you'll find adoption of these technologies become very hard. There's a lot of opposition. So have you ever encountered one, and how did you go about it?
Yeah, I think the major issue we encountered was during the collection of the data, some farmers not being ready to do the interviews. Of course, we had forms to sign that this data was only being used for research. So I think there is need for more, a way of encouraging feedback from farmers. That's common, but I think the best thing we can do is have ways to guarantee their privacy, and I think through that we can get some confidence and have more feedback from the interviewees.
Okay, thank you so much. I was asked to stop the session because we are wildly over time. I just want to say maybe the people from the Artemis team and the partners that are in the room, maybe they can raise their hands. So if you have any question, you can go to anybody of the team. Raise your hand, Artemis team, and yes, there. We are also at the exhibition booth. Not anymore? Not anymore. Okay, that was at the same time. Otherwise, maybe if you go there, you can still see our music video. We have a music video about our project, which is pretty cool, of course, right? Yeah, with that, thank you so much. And I think thank you so much for the panelists, Gustavo, Jacob, Steve, Violet, Chief Mischief. Very nice. And I'll hand it back to you. Thanks.
Thank you. Just last notes. I just want to thank you all. 4 hours, people. I'm so glad that room is almost full. So I just want to thank each and every speaker and the most amazing audience, unless Javu has some concluding remarks to say.
Just quickly, tomorrow we also have another session, digital theme session, opened by a keynote speaker from Busara and World Bank. And then we will have another 3 hours of science talk. So yeah, please come back 10:30 tomorrow. We will see you again. Thank you.